Welcome everyone. Good morning to the third and final public meeting of the study titled The Feasibility of Shore-Based Ballast Water Reception and Treatment Facilities in California. My name is George Isaac. I'm with the Delta Science Program. And today, I just want to let everyone know that this place is, we are webcasting the whole program today. And all public comments from the panel, comments from the public will be reviewed and considered for incorporation into the final report. I will now turn it to our Delta lead scientist for some introductory remarks, followed by brief introductions from the panel. John.
Great. Thank you, George. As George said, my name is John Calloway. I'm the lead scientist for the Delta Science Program, and I want to echo his welcome to the third meeting of the feasibility evaluation of shore-based ballast water reception and treatment facilities. Everyone here knows, and I'm sure the people watching on the web know, that invasive species are a challenging issue here in the Sacramento-San Joaquin Delta and the San Francisco Bay. They're a part of the Delta Plan and identified as one of the critical challenging issues for ecosystem restoration in the Delta Plan. The San Francisco estuary has been called one of the most invaded estuaries in the world. And this problem isn't limited to San Francisco Bay. It's a problem in any port and estuary all around the world and up and down the California coast. And as you all know, there's many mechanisms by which invasives get into these locations, but ballast water clearly is one of the major sources. So the state of California has made a commitment to reducing invasive introductions via ballast water. And the code requires that the State Lands Commission implement performance standards for the discharge of ballast water into the state water. So meeting those standards has been a challenge with on-vessel treatment, as you all know. So there's substantial interest in evaluating the feasibility of receiving ballast water on shore and using shore-based treatment. So a little over 2 years ago, the State Lands Commission requested the Delta Science Program put together a panel to address this issue and to evaluate the report that's being produced. And this request goes right in line with the Delta Science Program's mission, which is to provide the best possible scientific information for water and environmental decision-making in the Bay Delta decision. This issue isn't just within the Delta, it's definitely across the entire state. But one thing that the science program has done consistently is to facilitate independent peer review panels, as we've put together here, to evaluate the science and to help with policy recommendations. So the panel was given 13 specific questions in their charge. You can review their charge at the web page on the Delta Science Program's introduction to the panel and this meeting and their previous meetings. I'm not going to read all of their charge questions, but really the focus is to provide critical review and feedback on the report that is being produced by Gloston and their associates. And the report is to evaluate the feasibility of this issue of shore-based ballast water reception and treatment. So I know the panel went on a field trip yesterday to see the Stockton port, and I heard that was from George that was a very informative and useful. So we look forward to hearing your review, your questions and your review today. The previous reports have addressed the first 5 tasks of the report that's being developed, and today they'll be evaluating 8 tasks that are remaining, looking at outfall issues, at permitting, at cost and market considerations, and at implementation issues. So we, as I said, we look forward to hearing about the report and then hearing questions on it. So before I ask the panel to introduce themselves, I want to thank the planning team that started this off 2 years ago, putting everything together. Thank George Isaac from our staff, who's really made this go forward. Thank Gloston and your associates who have put together the documents and the report that the review panel is doing. And of course, our illustrious review panel that really brings together a wide range of expertise and perspectives to consider these issues. So now I'd like the panel just to introduce yourselves briefly.
Good morning. My name is Audrey Levine, and I'm currently based in Santa Cruz, California. I recently relocated to California from the Washington, D.C. area, where I was at the National Science Foundation, and I previously was also at the EPA. My area of expertise is environmental engineering and treatment technologies and water quality, and and my role in the panel is to overview those parts, but I'm also the lead author of our report. And so it's been really a pleasure to be part of this and really looking forward to the activities today.
Thanks, Audrey. My name's Bill Cooper. I'm a professor at the University of California, Irvine, and have done some work on shipboard ballast treatment. And my area is environmental chemistry, and I recently was in the Washington, D.C. area as the program director for environmental engineering for the National Science Foundation.
Good morning. I'm Christine Moffett. I'm a professor emerita at the University of Idaho. I have spent my career in fisheries and aquatic biology. I have worked a lot in invasive species control measures and am a member of the Western Regional Panel on Aquatic Nuisance Species, among other boards that I serve on, trying to protect invasive species from colonizing aquatic resources.
Good morning, everybody. I'm Steve Hackett. I'm professor of economics at Humboldt State University. I'm also associated faculty in the environmental science, environmental studies, and environmental resources engineering program at Humboldt State University. I started out at Indiana University way back when they were still inventing the wheel. My most recent research has focused on establishing socioeconomic baseline conditions for California's marine protected areas with a focus on the north coast of California.
George? And then I want to make one announcement. Rick Harkins, who was the fifth member of our panel, unfortunately had an accident and was not able to make it, and we've been trying to figure out how to get him in on some sort of a telephone connection, but he is a marine engineer located in Cleveland, Ohio.
Thanks, Bill. Yeah, we hope to hear from him through email, so if he has any questions, we'll try and receive it and repeat it. So today's presentation will be split into two halves. We'll have a morning portion with about 3 tasks in it. And those of you out there who want to comment, and after the presentation, we'll have a dialogue, a quick question from the panels, and then we'll have a final comments from the panel, after which we'll have some time for public comments. And those of you who want to make comments, please fill one of these blue cards and we'll call you up to the front. So we'll start the presentations today, and I would like to invite Kevin Reynolds from Gloston Incorporated.
Great. Thank you, George. I think maybe from the desk here, we'll just introduce the team. Maybe start here with Todd Graham from KPFF.
I'm Todd Graham with KPFF. I was helping out with port infrastructure modifications in that area. Consulting engineer to port.
Dennis King. I'm with the University of Maryland and King & Associates, and I'm an environmental economist, and I've been reviewing a lot of the economic work that Kevin's been doing.
Good morning. My name is Peter Souls. I'm with Gloston, project manager on this research project, and my background is in tug and barge operations and marine logistics.
Good morning. My name is Jean DeBrew. I'm with Kennedy Jenks, and I'm the water quality and treatment technology contributor on this project.
And just kind of shifted over here, Kevin Reynolds with Gloston. A little bit of background. I know I've said it before. Chief engineer for operating ships. Used to work in a shipyard as a construction engineer, overseeing the new builds and refits. And for the last 16 years at Gloston as a designer of ships with a focus on ballast water treatment. It's an absolute honor for myself and the team to have tackled this as we present our draft final reports. So you have this collection of really 13 reports in hand, a little bit unwieldy, covering an incredible number of topics. And today we're going to present topics 6 through 13. And for myself, at least, I find this absolutely fascinating, how everything from legal to can you meet a standard that's 1,000 times as strict as the international and federal standards to market implications. So very broad-ranging topic, very fascinating in these draft findings. We're looking forward to your feedback and what the council has to guide us as we look to finalize these reports. So these pictures up above, it depends on what lens you're looking at them from. If you're looking at them on this screen right here, it looks like a solid red box, the one all the way to the left. And if you strain your eyes and you peer very closely, the one in the middle, you'll actually see 10 little dots there. And the one on the right shows no dots whatsoever. So the international process for testing shipboard ballast treatment systems requires, and this is actually drawn to scale, a 1 cubic meter has to have at least 100,000 organisms to challenge a treatment technology. The international and the federal standards requires you to do a 99.97% reduction, essentially a almost 4-log reduction down to from 100,000 down to 10 or less organisms. California, in this case, is a no detectable. So on this slide here, circled those 10 from the 100,000 that you're allowed. So this was the challenge. Can we meet this with shore-based technologies, with the assumption that shipboard technologies could not in fact do this? So typically this size class greater than 50 microns considers zooplankton. If we look at phytoplankton, it's a little more interesting. With phytoplankton, if we look at a 100 milliliter sample, and these phytoplankton, really there is possible that protists could be included in this 10 micrometers, 10 microns to 50 micron size class. In 100 milliliters, again, it's 100,000 organisms that you need to test technology against when we're talking about shipboard technology. You're allowed by the international and federal standards to still have 1,000 organisms remaining. The California standard in that same sample of water must reduce it down to no more than 1 organism. So here we're looking at a standard that's 3-log additional reduction as compared to the federal and international standards. So just setting the stage here to understand what is the purpose. The purpose of this whole exercise is, can we, by employing shore-based technologies, effectively, practically, with minimal impact to commerce, to shipping, to safety, all these aspects, do this bigger reduction in live organisms that are going to be discharged from ships' ballast water. So we might have missed it a little bit. In task 5, the answer was yes, there are technologies, land-based, that can in fact meet these specific significant reductions. What is our, again, setting the stage here, this is 12.8 million tons of ballast water discharged annually from about 1,500 unique discharge events from ships spread throughout the state of California's ports. So in this, we look at then different types of vessels. What are their flow rates? How many ballast water discharge events do each one of these types of vessels have per year? We then look at a little different picture. So are these events repeated by the same vessels, or are these events a new vessel each and every time? And the answer is, it depends on the type of vessel. For example, you look at container ships, it's the same 278 ships that year after year are coming back to California with these discharges. If we look instead at bulk carriers, it's almost 1,200 ships that are responsible for the 570 annual discharges over a 5-year period. So there's a lot of new vessels that have never been to California every year in the bulk carriers that come to California. So these are interesting and important when we're trying to scale this up. We had a bit of a interlude during this process. We were very much focused on a land-based piping network. How can we take the ballast water from the ship, collect it, and bring it to the dock, and then pipe it from the dock to new wastewater treatment plants? So in Long Beach here, 50 miles of land-based piping. This is the network that our team spent a significant time drafting, understanding, looking at, and we said that's an incredible amount of piping. So from there, we talked with the council and said we want to look at barge-based as an alternative to bringing this to a piping network. So this is summarized in an April 2017 memo, a little out of scope. This was additional work to try to tackle. So from this, we then looked at shifting it to barges rather than 50 miles of piping. Can we have some number of barges that can pull alongside? The picture here is a little bit different. This is the Marine Invasive technology. It allows, connects up to a ship, you transfer it to the barge, and then it discharges overboard. A little bit different because this is designed to meet the international standard, which again is 1,000 times less stringent than the California interim standard. So don't be, just be cautious. This is an actual thing. This is built. They're practicing these operations in the Netherlands, but it does not meet the California interim standard, but it's a good visual to understand how you connect to and collect ballast water from ships to barges. So feedback from the council was looking at just LA Long Beach wasn't enough. What about a smaller port such as Humboldt Bay that only has a couple discharges per year? How does land-based piping compare to barge technologies? We took a look and we did a study on both of those. What would the cost of operating the barges be? We looked at a 30-year life cycle cost, so both capital and operations, expenses, chemical usage, energy, and we found in both cases that the barge base is less capital and operating cost, and almost more importantly, we couldn't, within our own team, we couldn't feel confident that in all locations we would be able to always bring the ballast water to land piping and wastewater treatment plants. And we felt comfortable that we could, in almost all locations, bring a barge alongside the ship and collect the water. So that technical uncertainty was almost as big of a driver in our recommending to the council that a barge approach is more reliable and cost-effective as compared to land piping. The panel came back and says he concurs with the concept of focusing on a barge-based system. In italics at the bottom there, you'll see a note from EPA. So this is from EPA's Vessel General Permit. And EPA in the Vessel General Permit notes that transferring ballast water to a treatment barge would, for eventual treatment and discharge could constitute onshore treatment. So this shift to a barge is recognized by EPA as an onshore treatment alternative, and it is in their regulatory regime. So just Peter's going to pick it up here in a moment, and he's going to talk about this other analyses. He's going to introduce this treatment barge. He's going to talk about how dividing up the state into zones to provide an overall network that would service all port locations. And he's going to talk about public-private partnerships. There's a picture of the zones. He'll go through that in some detail. I'll pick up afterwards the cost. And in cost, just start thinking that not all costs are, not everybody looks at cost the same. We came up with, what was it, let's see, we came up with, I think it was $3.43 billion as a 30-year life cycle cost overall. But part of that, about 1.5 of that, is what's the barge networks cost for them to build and operate. So think of it from the barge operator, treatment barge operator. The other is, what about the ship operators? Their cost is about $2 billion over that 30-year period. That's different. That's them refitting their ships, operating the equipment, and that's addition to them paying for the barge service network. The other way to think about this is, what about the cargo? If I'm shipping out a container, what's the cost to me for delivering that container, or for sending that ton of fossilized organic matter that we saw yesterday. On the timeline, we came up to something close to 7 years with some significant risks. We'll talk about that. We'll look at outfalls, how this is no significant change to what's currently being discharged in terms of dissolved materials, but it would increase the removal of live organisms, and it would increase the removal of particulate matter. So when we shift and we put a barge in that stream, how does that change the regulatory regime? Permitting and legal, we identified the different cognizant authorities, and each one of those authorities does have a path forward for onshore treatment, and we'll discuss those in some detail. However, there's a caution. That's Justice Kennedy. Oops, it's okay. That's Justice Kennedy, who ruled on what was originally Intertanko versus Locke and became United States versus Locke in the Supreme Court, talking about federal preemption of states' ability to dictate design and other aspects of ships. So that's a very careful thing. If implementing this network, we need to be careful that the state doesn't prescribe what the ship's modifications need to be and stays in the realm of requiring what the effluent needs to be. And we'll look at comparison. What are the other impacts? Does this increase air pollution? Yes, it would. Does it clean up the water in comparison? Yes, it would. Does it perhaps lead to additional congestion of the ports and actually congestion of the highways? Yes, it would. And current practices, we look at, are the ships able to always get to a treatment barge, or are they trying to discharge underway? Peter will talk about that. Market implications, we'll take this from really a perspective of the cargo. What's discretionary cargo that can be shifted to different locations in the state, can be shifted out of the state, and what's non-discretionary, and how is that going to impact commerce in California? So I'm going to hand it over to Peter here, and again, very broad-ranging set of issues that we tackled with our team, and very interested to present it to you and get the feedback from the panel on these draft findings.
Good morning, everybody. Let me get plugged in here. Okay, thanks. Good to go, yeah. Okay, thanks, Kevin, for the introduction. I'm going to talk for about 25 minutes reporting on task 13, which might seem a little bit out of sequence given that we last left off with task 5, but we used task 13 as a means to introduce one possible rollout of barge-based treatment throughout California. All the detailed analyses in tasks 6 through 12 are based on this example. So in this report, we explain the following: subdivision of the state into discrete operating zones, development of notional standardized barge designs, barge fleet composition across the state in terms of the number and mix of barges in each zone, and potential operating models, as well as options for monitoring and enforcement. Also in Task 13, we touch on potential impacts to port operations, port competitiveness, and certainty and convenience for ship operators. This photo does a pretty good job of capturing, in essence, a barge-based treatment approach. This is actually a fuel oil barge, of course, but it's analogous in many respects, including both the nature of the operation, a non-self-propelled barge handled by a tug alongside, and in the design and scale of the barge. What's not shown here is the ballast water treatment plant itself, which would be installed on the main deck. The one important point to clarify before I go forward, we're talking about mobile treatment barges as a shore-based approach, a variation of shore-based treatment in that the plants are located on shore-based barges and not on the ships that are actually carrying ballast water on coastal or transoceanic voyages. For the practical implementation of barge-based treatment, sorry, here I got some animations. We're recommending a zone approach, subdividing the state into a number of smaller operating areas, each with its own dedicated fleet of treatment barges. This simplifies management of vessel operations and ensures quality of service in localized areas. The zone approach is also robust in that it offers a high degree of reliability, adaptability, and scalability. Reliable because the barges would have considerable operational redundancy, both in terms of the onboard machinery, systems, and equipment, and in terms of the number of barges assigned to each zone. The zone approach is also adaptable because the standardized design and mobility of barges means that assets can be moved from zone to meet changing demands. Scalable because additional barges can be constructed and put into service to meet changing demands. And it's fairly immediate. Barges can be placed straight into service upon completion of construction without having to wait for fixed infrastructure. One thing I want to point out before I move on is the italicized text here. When we determine the number of barges for each zone, we use data to come up with a 99% of probability of barge availability, assuming that one barge is out of service. I'll touch on that again as we go forward. That may sound a little confusing, but you'll see as we go ahead here. In developing the specifics of a zone approach, we use data and some basic criteria based on expert judgment to devise 6 discrete operating zones, each with a different combination of standardized barge designs suited for the ballast water discharge activity in their respective areas. Collectively, we refer to the 6 zones as a barge network. The Task 13 report explores this concept in some detail and goes on to suggest one possible operating and governance model. This forms the basis of the more detailed analyses in tasks 6 through 12, as I mentioned. And in regards to operating and governance models, given that this would constitute a new and uncertain market, it's not clear that private companies would be eager to make the initial capital investment necessary to implement a network of treatment barges across the state. Because of this, and to reduce risk for all parties, a public-private partnership is suggested as being most likely to attract commercial participants. Under this model, the state would finance the construction of new treatment barges and grant exclusive operating licenses on a time, duration, and zone basis. So in summary, our findings on statewide barge ballast treatment are as follows. 1, the use of mobile treatment barges offers an effective means of servicing all ports in California for the reception and treatment of ships' ballast water. 2, these barges can be effectively dispersed throughout a port district or region to ensure that vessels can offload their ballast water at their current ballast water discharge rates. And lastly, there are several commercial approaches to implementing such a network of barges. Public-private partnership is suggested as a means to promote rapid implementation as well as effective service and pricing. In developing the zone approach, we relied on NBIC data exclusively to characterize ballast water discharge activity in California. We limited our data set to vessels arriving in California for the years 2011 through 2015. The data were sorted by location, by vessel type, and by discharge volume, and ballast water discharge activity was then analyzed for each of the 6 zones. The zone approach had to be developed in some detail to a point where we could carry out the required analyses in tasks 6 through 12. In other words, it was necessary to determine not only how many barges would be required across the state, but exactly what would these barges look like? How many different designs are necessary? What are the principal dimensions, their treatment capacities, and their retention or surge capacities for storage of untreated ballast? What sort of basic equipment do they have to have? And what's the required deck area for these treatment plants that would be installed? In developing notional barge designs for this purpose, we treated ballast water similarly to how petroleum products are treated from a liquids handling perspective. Therefore, we incorporated many design elements common to petroleum tank barges or bunker barges. This slide shows some of the basic design elements that we identified as general requirements. 3 notional barge designs were developed, small, medium, and large, with service capacities of 10,000, 20,000, and 35,000 tons. Based on our data analysis, we found these 3 standard designs would be capable of serving all California ports, provided that an appropriate mix is assigned to each zone. So this table shows the particulars and estimated construction costs for each standard design. We've got the small is a 200 by 62 barge with a treatment capacity of about 720 cubic meters per hour. The medium is a 240 by 74 barge with a treatment capacity just under 1,500 cubes an hour, and a 280 by 84 barge with a treatment capacity of about 2,500 cubic meters an hour. So for any vessels with discharge rates higher than the treatment rate of the barge that's alongside, adequate surge capacity is provided in the barge's internal tanks. The sizing of the barges was based on several factors, including the ability of tugs to safely maneuver and handle the barges within confined port waterways, the geometry of port waterways and controlling depths, and the ability of other vessel traffic to maneuver around ships while barges are rafted alongside, the required footprint for the ballast water treatment plants, and the deadweight capacity of the barges for storage of untreated ballast water. So this same slide that Kevin popped up, this is a conceptual drawing of the basic barge design, which would be more or less proportionally scaled for each of the 3 sizes. This slide shows the scale of the barges relative to one another. Okay, now I'm going to move into a description of the zones themselves. Before I do that, it's important to note that ballast water discharges in California are really concentrated into 2 main areas. The greater San Francisco Bay Delta area sees approximately 60% of the total annual discharge volume in the state, with the ports of LA Long Beach and these 2 offshore areas, El Segundo and Pacific Area Lightering, see approximately 40% of the total annual discharge volume. So despite that, though, it's impractical to provide statewide treatment barge services with state waters divided into just 2 sub-areas. This is mainly because the Bay Delta area is vast. Marine terminals are scattered from Redwood City to the south all the way up to West Sacramento in the north. Also, there are several comparatively small ports along the California coast that see very little ballast water discharge activity, but still require reception and treatment services. Lastly, San Diego is kind of a weird outlier. It's a major U.S. seaport, and it requires its own dedicated treatment barges, despite the fact that it has very little discharge activity relative to other California ports. And I'll explain that more as we go. These factors were taken into consideration in determining the physical boundaries of each zone. The operating radius for a fleet of treatment barges has to be something manageable, Can the barges respond to callouts within a reasonable time frame, given the distance between discharge locations? Physical grouping of marine terminals and ports, are they widely dispersed or are they mainly concentrated in one area? Where are the areas where frequent or high volume discharges tend to be concentrated? Where are the areas of infrequent or low volume discharges? And lastly, what challenges are there related to servicing remote or isolated areas? So this is the first of the 6 zones that we developed. Zone 1, San Francisco Bay, North Part, and Humboldt Bay. Treatment barges would be permanently stationed in this area and would provide satellite service to Humboldt Bay on an as-needed basis. In this zone, the Port of Richmond encompasses all actively used commercial ship berths in the northern portion of San Francisco Bay. All marine terminals are located within about a 2-mile radius of Point Potrero. So I don't know if you can see it, but I just turned on a yellow circle there. This relatively small area sees 13% of the ballast water discharge events that occur annually in California, and 15% of the total volume on average. Discharges are almost uniformly from ballast-dependent vessels, tankers, bulkers. And of the 6 zones identified, this area is closest to Humboldt Bay, which sees only 10 discharge events per year on average. Okay, these 2 figures show ballast water discharges by port, with total volume on the left and number of events on the right. These figures show a breakdown of individual discharges by vessel type on the left, and the average number of discharge events as a function of volume on the right. As you can see, discharges are overwhelmingly from tank vessels, and 66% of the discharges are less than 10,000 tons. 28% are discharges between 10,000 and 20,000 tons. So again, to achieve a 99% probability of barge availability, assuming one barge is out of service for dry docking or mechanical breakdown or whatever, this zone requires 2 barges, two large barges, 1 medium-sized barge, and 1 small barge. Okay. Zone 2 is San Francisco Bay, South Part, and Monterey Bay. Treatment barges would be stationed here, but provide satellite service to Monterey Bay ports on an as-needed basis. Marine terminals in this area are concentrated primarily at the northern end at the ports of San Francisco, Oakland, and Alameda. And there goes another red circle there, so you can see where most of the discharge activity goes on. That noted, Redwood City, 23 miles to the south, there goes another little circle, would require treatment barge services on occasion, about 15 times per year on average, and that's a 3-hour transit each way. This zone has a more varied mix of marine terminal and vessel types than in comparison to Zone 1. The number and volume of discharge events per year is about equal, though, 13% and 14% of the state totals. Of the 6 zones identified, this area is located closest to Monterey and Moss Landing, so it would provide satellite service to those areas. Moss Landing had only 1 reported discharge in the last 5 years. Monterey had 0. Here again is a look at the ballast water discharges by port, total volume on the left and number of events on the right. And in the next slide, discharges by vessel type show a broader mix than Zone 1, but still mostly tank vessels and bulk carriers. 69% of the discharges are less than 10,000 metric tons, and 24% of the discharges are between 10 and 20. It's really similar to Zone 1. Okay, this zone requires, again, for 99% probability of barge availability, with 1 barge out of service, 2 large barges, and 2 small barges. Zone 3. Zone 3 encompasses Carquinez Strait and Sassoon Bay. Barges would provide satellite service to West Sacramento on an as-needed basis. Zone 3 is interesting. It's a ribbon of geographically dispersed marine terminals along an almost 30 nautical mile long stretch of waterway. Discharges are mostly from ballast-dependent vessels, tankers, and bulkers. The majority of the discharges occur at ports and terminals in Carquinez Strait, which is at the west end near the Rodeo Benicia Martinez. But about 1/3 of the total volume is discharged in Pittsburgh near the opposite end. Annual discharge volumes in West Sacramento are pretty low, but there are still 30 discharge events there per year on average. So treatment barges would need to call Sacramento roughly once every 2 weeks, which is an 8-hour transit each way. Here's a look at Carquinez Strait looking east with Sassoon Bay in the background. The discharge stats are quite a bit more varied here, as you can see. Clearly, treatment barges would need to move around quite a bit within the zone to cover each of these ports, though the greatest number of discharge events occur toward the west end, like I said, in the area around Rodeo, Benicia, and Martinez. While the vessel mix is still predominantly ballast-dependent vessels, this area sees a slightly higher percentage of discharges in the 10 to 20,000 ton range. This zone requires 2 large barges, 1 medium barge, and 1 small barge. Zone 4 is limited to the Port of Stockton, with no satellite service to other ports. In our opinion, it's logical to have a dedicated fleet of barges in this area because it's pretty geographically isolated from the other Bay Delta ports. It's approximately 55 nautical miles from San Pablo Bay. And this small area, which is less than 1 square mile, sees only 5% of the ballast water discharge events that occur annually in California, but 20% of the total volume, which is pretty remarkable. Discharge volumes are almost uniformly from a single vessel type, bulk carriers, and as you'll see in the statistics in the next couple slides here, discharge activity here is characterized by a high percentage of high volume discharges relative to the other zones. So here is a glance at the Port of Stockton East Complex. It gives you a sense of scale, and it gives you a sense of the port's inland location. Discharges in Stockton, like I said, are almost uniformly from bulk carriers, and almost 50% of the discharges are greater than 10,000 tons. 24% of the discharges are greater than 20,000 metric tons, while 10% of the discharges are greater than 30,000 metric tons. While large discharges like these occur elsewhere in California, we don't see them in similar ratios in any of the other 5 zones. This zone requires 2 large barges, 1 medium barge. Okay. Zone 5. Zone 5 encompasses the ports of LA, Long Beach, and vicinity, including multiple satellite service areas. Barges would be based within LA Long Beach proper and provide regular service for the offshore areas of El Segundo and Pacific area lightering. Avalon, Santa Barbara, and Port Hueneme would be served on an as-needed basis. This zone is distinctly different from all other network zones. By almost any metric, it's the busiest port complex in the United States, with an average annual number of discharge events greater than all other zones combined, almost 1,000 discharges per year. The total annual discharge volumes in Zone 5 are more than twice that of any other zone, accounting for 42% of the total volume discharged annually in California, all within an approximately 30 square mile area. The requirement here to provide regular barge service at locations offshore, 2 locations, 60 nautical miles apart, is totally unique to this zone. And the satellite locations that I just mentioned, Avalon, Santa Barbara, and Port Hueneme, they can't be practically served by another zone. The port breakdown shows that the vast majority of discharges, both by volume and by frequency, occur within San Pedro Bay proper. The offshore areas of El Segundo and Pacific area lightering account for about 18% of the total volume and just 10% of the total number of events. Discharges at the satellite areas are practically negligible. Ballast-dependent vessels still dominate, but almost 80% of the discharges, more than 700 per year on average, are less than 10,000 metric tons. So a whole lot of small discharges in LALB. This zone requires 3 large barges, 1 medium-sized barge, and 3 small barges. Why is that not showing? Oh, there we go. I must have had a duplicate slide in there. Okay, Zone 6 encompasses Point Loma and San Diego Bay with no satellite service areas. This area is somewhat unique in that shipping activities dominated by military, general cargo, and ro-ro vessels that can be characterized as non-ballast dependent. Ballast water discharges are both infrequent and small in volume relative to the other zones. Almost 100% of discharges here are under 10,000 tons. It sees only 30 discharge events per year on average, but it's located roughly 85 nautical miles from LAL Beach, so it's somewhat removed. And serving San Diego as a satellite would likely present big challenges related to barge availability in Zone 5, given the expected demand there. Here we see it's dominated by other vessel types, and again, nearly 100% of the discharges less than 10,000 tons. These are non-ballast dependent vessels. All that's needed here are 2 small barges. The only reason you need 2 is because if one's out of service, you have to be able to provide service. So. Okay, here's a look at discharges across the entire state by zone, for both volume and frequency. So as you can see, zones 1, 2, and 3, which is pink, orange, and blue, are pretty evenly balanced, with zone 4 just slightly behind. So the zones are pretty well apportioned in terms of ballast water discharge activity. But clearly zone 5 is a totally different animal. But again, 80% of those discharges are within the small 30 square mile area inside the breakwater. This table shows the fleet composition for the entire statewide network, 24 barges in all. And here it is pictorially, if you're a visual learner like me. Sorry, here we go. 24 barges. Okay, at this point, I'm going to shift gears a little bit and touch on some of the operational considerations related to a barge-based approach, though I'm going to have to move through the slides pretty quickly in the interest of time. Also, many of these topics are discussed in more detail in the associated task reports. These are some of the basic operational elements of a barge-based approach that would have to be taken into consideration and fleshed out prior to an actual network design and prior to statewide implementation. Give you a second to kind of glance over those. We identify in Task 13 6 potential business models for barge-based treatment throughout the state. Each of these is described briefly in the report, but with a focus on public-private partnership as the suggested model. Public-private partnership. It's a mechanism for government to procure and implement public infrastructure and or services using the resources and expertise of the private sector. Public-private partnerships are often selected where the initial capital investment is high and there's risks for private sector investors because of new or uncertain market conditions. Under this model, California would finance the initial capital investment and private companies would build and operate fleets of treatment barges to operate in one or more zones. The state could develop licensing agreements that offer a private company exclusive access to provide service in a particular zone. This would provide a revenue stream for the state and a mechanism to control fees and potentially to support certain ports that might otherwise be might face a competitive disadvantage. Licensees would directly charge the marine vessels that they service, and the rate structure could be based on different combinations of minimum call-outs to provide service, total time alongside, and the quantity of ballast water processed, type of vessel, discharge rate, which can drive a requirement for one of the larger barges, or any special handling requirements, as well as any offsets mandated by the state, such as rate reductions for remote ports or other considerations. After lunch, Kevin will go into more detail on the topic of port competitiveness and presenting on Task 12, which is market impacts. But the important takeaway points are that shore-based treatment does have the potential to affect movement of cargo through California ports. Remote ports, or those that see little discharge activity, may be adversely affected. To minimize this, the state might consider models where a licensee must charge the same rate regardless of the discharge location within a specific zone, meaning, for example, no additional fee related to transiting 23 miles south to service Redwood City. Also, in some cases, the state might need to pay a licensee to maintain service in locations that might otherwise see a reduction in cargo volumes or vessel calls as a result of comparatively high ballast water reception fees. So Kevin's going to dig into this much more, but for areas such as potentially Stockton, potentially San Diego, because of the less frequency of ballast water discharge activity, the costs can't be spread. So anyway, I'll let him pick up on that. So while the barge-based approach appears much more practical and adaptable than a system of in-ground piping, it's not completely without impact to ship operators. Certainly, for discharging vessels, port operations will take longer and they will be more expensive. This constitutes this being a barge-based service. It would constitute an additional service in addition to all the things that ships already do while they're at the berth, and an additional line item in their total combined port call cost. And for ballast-dependent vessels in particular, it's likely to be much higher than all other port call line items, such as wharfage, pilotage, assist tugs, and line handling fees. It also complicates the scheduling and the provision of other services, such as the delivery of lubricants, bunkers, and stores. Lastly, I have a few bullets on monitoring and enforcement. I'm going to let Kevin delve into that too when he presents on permitting and legal, but the main headline here is treatment barges would likely be permitted under the U.S. EPA NPDES system, but it's not totally straightforward. It's complicated by the salinity of the seawater. Okay, nevertheless, relative to shore-based treatment on land, a network of treatment barges offers significant advantages for practical implementation of shore-based treatment in California. Thanks for paying attention during a rather long presentation. And now that I've laid this groundwork, we can move on to answering some of the important questions within the tasks 6 through 12. Thanks.
Well, thanks, Peter, for introducing the barge network, Task 13. Again, at Task 13, that was our other findings. So the other findings in this whole process are very significant. So as we look through Task 13 and implementing, there's this section talks about cost. So $3.63 billion, that's an estimate for total cost of ownership for 30-year life cycle of implementing barge-based treatment or shore-based treatment in California. That includes the $127 million. That's what's the expense to the shipping industry. Let me make sure I get this right. Every year, the shipping industry will need to spend $127 million to refit new vessels that have not yet called in California. So imagine in year 2025, there's going to be a host of vessels that haven't been to California yet that need to do some retrofits. So in 2026, there's going to be another host of vessels that are going to spend $127 million to refit their vessels. So that's an ongoing expense to the shipping industry from that lens. The $552 million, that's from the perspective of what's the initial capital expense for building these 24 barges that Peter talked about. So when, the numbers could stop where, what's it take to implement a barge-based network? Well, just $500 million and you build these barges and they run themselves. And the ships, they'll just be ready for it, right? That's a rather limited and narrow answer. But for that perspective, that 552 million is the right number. The $36,751, that's the cost for a single ship call. So in that zone 5, which is the highest utilization where lots of vessels are coming through, we have these, I think it was 7 barges of different sizes, this nice network running at quite an efficient operation. $36,000 is the average cost for them to come to a particular marine vessel, have the tugboats push them alongside, pay off the investment in building those barges, and then charge to the vessel operator, here's our cost for having people on staff, the time to do that service call. $46.38, that's an estimate for if you amortize that cost across a passenger vessel calling in Long Beach, what would that cost be per passenger? So obviously this is a lot of dense material on these costs here, but hopefully those numbers can give people a little bit of a tactile feel for different ways of dividing up these costs. So the first set there is how do we get the cost for marine vessels? Back in Task 2, we talked quite a lot about these ballast water transfer stations. What do you need to do to these existing vessels that are normally discharging the ballast water through overboards in the side shell or even down through the sea chest quite low? They now need to lift this water up all the way up to the main deck and do outfitting with transfer stations so you can secure hoses and you can have lighting, communications. In some cases, like cruise ships and car carriers, you need to put in new side ports so the vessels can attach these hoses. So what are those expenses? We look at the structure, the auxiliary machinery, the outfitting, the approvals, the engineering, and we came up with those costs there. So those are on a per vessel type expense. So for example, if you're running a bulk carrier, you could be looking at $300,000 of expense to take your 24 or 32-inch pipe and bring it up to the main deck and have appropriate equipment there. Next, we take a look and say, okay, well, how many new vessels each year are showing up that have never been to California before? So mining the NBIC Coast Guard's database, looking at unique vessel calls that are discharging and accounting for some vessels that may show up in California but choose not to discharge, we come up with the numbers for how many vessels need to bear those particular costs. And that's how we get a per vessel type outfitting cost. It's moving towards that $100+ million per year of outfitting. We then look at operations. What's the total volume treated, which then gives us energy cost for the vessel to essentially do additional pumping of this water? What's the personnel cost for watching this connection? Remember at the workshop 2, we discussed and agreed that we should treat this like an oil transfer, that spilling ballast water into the local harbors that hasn't been treated, that should be dealt with similar to an oil spill. So having leakage and so forth is not acceptable. And when we're doing oil transfers, petroleum transfers, we stage people to watch these connections, and we have careful communications between the ship and the barge. So there's an expense there to have people on hand. So from here, we get the operations cost for the vessel. Taking that and applying it not on a per vessel basis, but per discharge basis. So how many discharges do we have each year? And you might see in some cases we're using 1,500 discharges per year. Other times we're using 1,700 discharges per year. It's a matter of which years we're grabbing our numbers from, and some cyclical effects, whether we're looking at 2010 to 2015, or we're incorporating the uptick in discharges in 2016 and 2017. Pulling it all together for each vessel type, for example, we're looking at tankers, about a $528 million life cycle cost for this, for implementing this just on that sector of the industry's behalf. In other words, this is a cost that the barge network might not see. It's a cost that the ship operators would see. If we look at, for example, passenger ships, maybe $18–19 million of expense across the industry in today's dollars, assuming 30 years. So cost for the treatment barge. So this is not what the ship operators are bearing internally, but this is the state in a public-private partnership working with an operator or operators that says, okay, let's build this barge network of 24 barges and let's operate this. Let's see what this would look like. So there's, again, an image of the barge. And on this, we look at the particulars. These barges will go a little bit into the design, but they're taking the water in where they're allowing the water to some settling. There's different ways of flocculating. Here we're showing perhaps a older method, a more known method to flocculate the particles in the ballast water to then bring it to plate separators, then bring it through membrane filters, UV treatment process, and then an overboard discharge, or in the more land-based terminology, an outfall. So each of these 3 barges at the 10,000 tons capacity, so smaller vessels that have 10,000 or less tons of capacity, that's the throughput rate with which we can treat the water. And again, for the medium barge at 20,000 and a large barge at handling a 35,000 tons of ballast water discharge over that period. For example, we're looking at, for the small barge, 180 kilowatts of power. That would drive not only the operating costs, because we need to burn fuel to hit that capacity, but also installation costs, because we need generators and we need electrical wiring, et cetera, to take care of that. When we look at the barge particulars, these barges are double hull, again, treating it like oil. So we look at, we use standard costing metrics for just the steel hull itself. What's the material cost? Looking at the cost of a crane, looking at the cost of pumps and electrical generators, and get costs for those barges. And these are fairly complicated. They're very similar to tank barges in terms of pumping equipment. So, for example, the small barge, we're estimating about $6 million for a fully outfitted delivered barge. The large barge, almost $15 million. These are very high cost relative to, say, a deck barge. And it's because these barges have superstructure. These barges have some complex handling equipment to actually capture and receive these large volumes of water. When we total the treatment plant and the barge costs together, we get about 11, 17, and $25 million for the small, medium, and large barges. So now let's think about this in terms of zone. So we know those estimated costs per barge. We then simply apply how many per zone, small, medium, and large barges we have. And we know, for example, in Zone 5, it's about $125 million worth of, just call it hardware, that needs to be supplied for the barge network. Total cost to the public-private partnership is about $500 million to build these 24 barges with treatment plants and the barge structure, outfitting, pumps, et cetera. So if we then take those numbers and we add in engineering cost, we add in permitting, we look at some contingency for, this is obviously a rough order of magnitude cost. We then project that for the timeline at which these barges would be constructed. For example, we probably wouldn't start barge construction for about 3 or 4 years. So, and then we bring that cost back to today's dollars, we end up with about $550 million for the capital expense of bringing this network online. For the operating particulars, Peter did a nice job, I think, of giving a visual overlay of what these zones look like. There is quite a bit of cost associated with not only the barges, but how much ballast water are we actually handling? It costs more money to turn the equipment on and run it. You're burning fuel, you're using flocculant. It costs money to hire tugboats to shift this barge from its current location to, say, in the case of El Segundo, that's a long push from LALB out to El Segundo, and it takes quite a lot of time. Where in some cases in San Diego, the distances might be quite short. So we look at those different distances that the barges would need to be pushed around and how much ballast water it's actually treating in terms of operating expense. And perhaps most importantly, it's really our biggest cost is going to come in just having a call out. If you're showing up to treat 10,000 or 15,000 tons of water, that volume difference isn't going to be the big driver. The big driver is going to be just getting the barge there, doing the tie-up activities, making the connections. So when accounting for those, we then get total operations, maintenance, and repair expenses based on those distances, based on those utilizations by zone, giving us on an annual basis in California about maybe $50 million in operating expenses to run this network. Now keep in mind, in putting these costs together, this does not include a profit for that public-private partnership. So that's one thing that needs to be kept in mind. What profit would the public-private partnership, would the state want the private entity to have here? Bringing it all together, when we're looking at the operating cost and the capital expenses over that 30 years, looking at a 6% discount rate, 2.5% inflation, and then 3% on what's the cost of fuel and chemicals over time. So separating those a little bit, we're at about $1.5 billion for the barge, the private-public partnership barge network. So the first hat was looking at it from the ship operator. The second hat was, okay, if I'm running a barge network. And now the third quite important hat is, what if I'm the cargo? What if I'm a passenger getting on board a vessel? What does that look like? And I have to say, it's very difficult to try to get to a metric on per ton basis or per 20-foot equivalent unit container metric. But here we're doing our best to estimate these costs. The first is really, it's quite easy. If we just look at the number of discharges, for example, in Zone 1, San Francisco Bay North, we have 236 discharges. We know we have a 1.94 million metric tons of ballast water. The average volume, 8,220 metric tons of ballast water each discharge. And the cost per discharge, we could then say, is $61,000 based on amortizing that barge network cost across that zone. And we come up with a nice easy number, about $7.50 per metric ton. So that's not so hard to do. I feel pretty good about that math. On average, we can say, yeah, we're somewhere in the $7 or $8 range when we exclude San Diego. San Diego is a great example because they just don't discharge ballast water much at all. I mean, Peter, how many ballast chart events were we looking at in San Diego? 30 a year? So we've got 2 barges that cost tens of millions of dollars to build, and then we got to mobilize them for 30 discharges. I mean, that's a utilization rate of each barge 15, so I don't know, what's 15 divided by 365 days? I mean, it's an idle asset. So you're looking at almost $120,000 just to call out that barge if you actually want to have that zone pay for itself. We'll talk about this a little bit in market implications. Should a zone pay for itself, or should the state try to smear those costs across the state and essentially have LALB cargo in fees helping pay for San Diego, so San Diego's costs aren't disproportionately high? But without doing that, we're talking $120,000 per ship call-out, and as Peter noted, these ballast water volume discharges are very low, and we end up with about $100 to capture and treat each metric ton of ballast water. So you see, things get quite messy here. If we now think about bulkers and tankers, we're still in pretty reasonable ground. Just the design of highly dependent ships, ships that carry bulk cargo, where it's really a weight exercise. You're looking at about 1/3 to 1/4 of its cargo capacity needs to get replaced with ballast water. If I come in with 100,000 tons of, if I need to load 100,000 tons of bulk cargo, whether it's oil or it's grain, I need to fill about 25,000, I need to discharge about 25,000 tons of ballast water. So my ratios there as 1/3 or 1/4 are fairly reliable. So the cost per zone that actually has tanker and bulker discharges, we're looking there, $2–3 per metric ton of ballast water treated. So I take that typical cost per zone, say $36,000. I look at how much for the LALB location. I then take a look at how much ballast water I'm discharging, how much cargo I'm loading, how much ballast water I'm discharging, and I get to those numbers. It's much more difficult for a container ship. So if I'm launching just say I'm an LALB, $36,000 to show up and service your vessel, and you're offloading 14,000 containers, I can amortize, that cost over 14,000 TEU equivalents. That ends up with a pretty low cost. If instead I'm in San Diego and it's cost me $180,000 to show up and do your service your ballast water, and you're only discharging 1,000 TEU, that ends up being a very, very high cost. So you can see that this is going to be a pretty high cost for low volume operations in remote ports. So here, cost per TEU, we're looking at $7 in San Francisco South, and maybe we're looking at $1.38 per TEU when we're in LALB. Car carriers and passenger ships, again, it's the same sort of effect. If I'm, again, at a high volume operation, but I'm in Port Hueneme, I'm going to have a very different cost than if I'm in San Diego. So looking at zones 1 and 2, my low and high costs are quite similar because I'm typically discharging about 8,000 car equivalent units in those locations. Those costs at those two locations for barge treatments are quite similar, so about $7 or $8 per car. If I'm in LALB, because my per ship call costs are much lower, I'm down, I'm sorry, yeah, it just depends. If when you look at LALB and you look specifically at the ships that are discharging, some of those ships are only discharging 1,200 car equivalent units. So in that case, my cost could be up to $30 per car simply because I don't have the volume to amortize it across. Once I get to San Diego, it's that quite similar problem where their volumes, the specific ships that are actually discharging, they're only doing about 1,200 car equivalent units. And with that, you amortize at much higher cost, you're about $100 a car. We're looking at cruise ships. Again, it's the cost for sending the barge out there to do the service, and you amortize it against the number of passengers. You could be looking at, our low number there is 490 passengers, and our high numbers can be almost 3,500 passengers, giving us wide fluctuations, anything from $10 per passenger up to $123 per passenger for handling this cargo, for handling the ballast water. So this summary, this chart here just gives that summary. Again, looking at the shipping industry, about $2.17 billion across a 30-year life cycle. Looking at every single year investing $127 million to refit their ships, about $7.6 million in operating cost. Most of that is watching the equipment, tending the hose. And this does not include what the shipping industry would need to pay the barge network. From the treatment barge network, about $1.45 billion in a 30-year life cycle cost, about $500 million for the initial investment to build the network. Each year, about $55 million in cost, including the tugs. Although this does not include profit. From the ship operator perspective, looking at quite a wide range. If you're up in Stockton, about $120,000 for each ballasting event to pay. And if you're in LALB, you're down to $36,000. If you're up in San Francisco, I believe that was around $60,000. So quite a per vessel movement expense here. As far as cargo shipment, a good average number is about $2.18 per metric ton of bulk cargo, whether it's tankers or bulkers. A good estimate on average for 20-foot equivalent unit is about $19 per TEU, $11 for cars, maybe $50 for passengers. And again, that doesn't include the shipping industry cost. In other words, what the ship itself is already paying for to outfit its ship and to support these operations, and it doesn't include profit. Okay. All right. Peter says we were tight on time, so timely subject would be the implementation timeline. So when we're thinking, again, encourage folks to think of the different hats for the timeline. So the first part for the timeline is really going to be, what does it take to go through the permitting process? This is a big deal because it can impact how we design the treatment barges. We're estimating to get a statewide NPDES permit from the California Water Board is 2 to 3 years. And there's a lot of study that needs to happen, a lot of discussion. In particular, we'll cover this afternoon, discussion of discharging salty water in freshwater ports. So number one, think about the permitting process. Number two, building these barges, there's quite a little bit of effort there. It's 24 barges it's not unheard of in the marine industry to have a build program like that. It's manageable, but it's still a significant effort. We're looking at about 5 years to roll out those barges. That would include regulatory permitting in terms of making sure they're safe to operate. It would include phasing those barges in. It would include the design efforts for them. In the big picture, those barges are not terribly difficult. The treatment plants, shifting this equipment from shore technologies, land-based technologies, onto the barge does require a prototyping round. So in doing that prototyping and coming up with understanding what are lessons that need to get learned there, it's going to take a year and a half. Then building those would fall and dovetail in with the barge construction. Then the last piece to think about, and it's easy to miss, but it's critically important, is the ships, fitting them themselves. It's quite the chicken and egg here, right? Do you build all of these barges, so you have 24 barges sitting there idle, and then you tell the shipping industry, okay, everybody, start refitting your ships with these ballast transfer stations on deck? Or do you have a whole shipping industry put these barge transfer stations on deck? And you go, okay, good, they did it, so now we're going to build the barge network to suit. And don't forget that, particularly for bulkers, a lot of those vessels don't know that they're coming. So in other words, they might only call in California once in their lifetime. So ships have about a 5-year dry docking schedule. Most of these sort of implementations happens over actually a 6-year period. Most vessels can ask for an additional year allowance in that 5-year regulatory scheduled dry dock. So it takes about 6 years, once we know what we want to do, to get the shipping industry to build those, to do that outfitting, pull that together. So I'll just leave it with this slide here. I think it shows the whole story. Up on the top is the permitting. The next piece there is research and development of the ballast water treatment, shifting that technology onto the barge. We then dovetail that. That then leads into actual construction of the barges, the large, small, and medium barge. And on the bottom there is the shipboard modifications. The way we've laid it out here is that the ship modifications will need to happen starting quite soon in this 7-year timeline. And that means that we'll be looking at the first year, 20% of the vessels coming in with a ballast transfer station looking for service. We hope that we'd be able to have some of the barges ready to receive that ballast water. However, when you think about the network, what do you do in San Diego? Do you put the first barge that rolls out of the network production down in San Diego to capture 30 vessels that might show up in a year? Or do you put them in LALB where you have a high amount of traffic? What is the ship operator then, who's in that first year of implementation and has this transfer station, how do they feel when they show up in Port Hueneme and we don't have a barge there to service them because we've only produced 1/3 of the barges? So like anything, the rollout's going to be bumpy, and we're proposing that we'd roll both the ship retrofits and the barge network out together, acknowledging that over this 7-year period, there's going to be some unevenness where we'll have barges idle, where ships are showing up without the treatment, without the transfer station available, and we'll have ships showing up with the ballast transfer station looking for service, and we wouldn't have a barge there to serve it. That covers the timeline. Okay. So George, I think it's back to you.
I'll kick it off. Looking at San Diego, with 28 port calls, ballasting operations, can't you think about maybe actually a land-based thing there rather than even worrying about the barges? I mean, I think we need to say that we really want to make sure that every ship that's discharging ballast water gets it treated, okay? And so why, I mean, you've been kind of rigid in your economic analysis, but if you've only got 28 calls a year, and I don't know, honestly don't know the San Diego Bay, but I mean, that just seems like it would be an obvious thing for you to cost out, is how could you actually use a land-based, a true land-based, not one of barge?
I think the April scale-up exercise, looking at Humboldt Bay with only 2 discharges in that period, we still found, even in Humboldt Bay, which is a geographically smaller area, less developed than San Diego, we still found it to be a significant cost advantage. Now, that noted.
You mean to go with the barge system?
To go with the barge system. So in that April memo, that lays that extreme out. That noted, what we're trying to do is to present a doable alternative, something that we can put our hands on and say, with this cost and this approach, you can service California. I think absolutely, when it comes to implementation, there'll be locations where additional study or additional work would find that a land-based piping network might be the better answer and might give you a better cost advantage. So the reason to stick with the barge network throughout the entire state is it's well understood, and we're confident that it'll work. But as it gets implemented, by all means, I think some land-based piping could become part of the overall solution.
I mean, for Humboldt, if you've only got 2 a year, why don't you just have barges that don't have a treatment system on them and just use a barge up there? It'd be much cheaper to just take that barge and bring it down to San Francisco where you have a treatment system, yeah. Christine?
Well, that was just, I was going to clarify that one of our earlier meetings, we had talked about storage vessels. And a number of us have considered that this should be probably put into the mix in terms of understanding the economics and providing, still using the same system, but a barge with the storage tank rather than a treatment tank. And so I think that segues to what Bill's talking about.
We looked at in the case studies, the original 5, one of those aspects was doing a storage for the cruise ships, because those are quite a nice small piece, and you collect that in a barge, and then you bring it over to what was the Navy mole and putting in a treatment plant there. We gave some thought to, could you have essentially a feeder network, a little bit like fish processors work, where there's catchers that go and collect the materials, and then there's a processor, which is another vessel that then receives those materials and does the processing. So again, I think that there's some small number of discharges and locations where that could work, but we found that the additional expense of building a larger barge to capture the water and then do the transfer, that you eat up that expense in the transit between the different barges. And then, in other words, the treatment equipment on board becomes not that much when you compare it to the operations for doing that transfer, doing that transit, and making sure the vessel has enough volume. Essentially, we would end up needing maybe not 24 barges, but maybe 30 barges, with the additional 6 just running around collecting small amounts of ballast.
It would be nice in transparency to provide us those scenarios, because there's been sort of a difficulty following through some of the assumptions that are met in that.
I was going to save this for after the break, but since Christine brought this issue up, I may as well follow on the train here. So my understanding is that the number of barges was estimated based on annual discharge information. And it occurs to me that there's bound to be peaks and troughs in terms of the demand for treatment services, which strikes me as a bit of a peak load problem similar to a public electric utility serving load. And, part of this issue relates to storage, but I think more generally, thinking about essentially making a capital investment decision based on fluctuating levels of service load. the way I read the report material didn't speak to that issue, and I guess I'm wondering how fluctuations in treatment load affects the capital budgeting problem at hand here. I'll have other questions relating to barge-related costs and economics too. Thank you.
Sure. Yeah, we did quite a bit of mining of the NBIC database, and we were looking at frequency, not at averages. And in the frequencies, for example, quite a lot of work to take a look at what was the percentage of the time that 2 vessels were discharging at the same time, or 3 vessels were discharging at the same time. And we picked 99% reliability just as a reasonable number. So, and then 1 vessel out of service on top of that. So it's very true. We're going to have to reach that level of availability of the barge service network. We're going to have a significant number of assets underutilized or sitting idle a great deal of the time. So if you take San Francisco, for example, if you just averaged and you assumed that there were no peaks, we would have quite a few less barges. So anyway, short answer is we very much considered frequency of discharges combined with the volume to make sure we got that coverage. And it does result in a significantly higher number of barges to do that, to provide that availability.
Thank you very much.
So you cleverly switched from San Diego to Port Juanita, or to Humboldt Bay, but going back to San Diego, you have 28 discharges per year with only 0.03 MTs. I forgot what MTs is. It's million metric tons. So that's like nothing.
Or I'm sorry, that would be 1 million metric tons.
Even so, yeah, I mean, you've got 28 discharges. That's on average, which we don't like, but on average, it's maybe 1 every couple of weeks. I just don't see the cost. I can't believe that the cost of a barge with a treatment system on it for 2 barges at San Diego would pencil out. I mean, just bring the stuff up to Long Beach and Los Angeles where you've got a whole bunch of stuff going on. It just doesn't seem to me at a 30,000-foot level that putting 2 barges in San Diego makes any sense with the treatment systems on it. And with that small amount of discharge and only 28 port calls. I think what I'm thinking is that, and I'm not an economist, but you got to put some flexibility in this economic analysis if it really wants to make sense. That's my point.
Point and request well noted. Yeah, it's
And you can't deflect the Humboldt.
no, well noted. We'll take a look.
Well, the storage, it's kind of like in the stormwater world, you intermittently treat. So it seems like the storage sort of concept could be made to work as a kind of a holding basin that you can treat as needed or wait for all the, it just seems like that. We didn't see any of that in there. Another question I had that, or that we had, is that, so you've talked a lot about the ballast water and the treatment systems, but these treatment systems are removing solids or that form sludge. And we were wondering in the cost analysis, we didn't see the management of the solids and the sediment. How are those going to be taken? It sounds like they're going to somehow magically get to shore, but I didn't see that in the cost estimate. So I was curious about that.
Sure, we did cover the sludge in the outfalls section, and the cost was frankly fairly low in comparison to the overall cost. So it's something that we need to bring into the overall cost estimate. We don't see it changing the numbers significantly, but for completeness, we need to get them there.
And there might also be permitting attributes of that too. That once it gets on shore, then what? Right. So.
Yeah. So in the outfalls, it does discuss that permitting. And we do have permitting cost in the overall cost estimate, and that's assumed to be incorporated in that. As far as the storage aspects, it comes down to, if you're looking at LALB, for example, it makes sense to treat while you're receiving. So that's fairly easy to see. If we're looking at, for example, Stockton, in large ballast water discharge volumes, the barges just aren't big enough to collect that volume of water. A barge that can collect 35,000 metric tons is going to block the waterway. We're just too large. Where your question and Bill's question both are quite valid, to take a second look at locations where the volumes are small and the frequencies are infrequent, and what can we do in just in terms of then towing that up to a place that has a treatment vessel that can meet California's interim standard. So we'll take a second look at that.
The Humboldt example is that all the discharges up there are large. They're bulk carriers. And so what we're depending on is a barge that has the capability to treat at a throughput rate of 2750 cubes per hour. And then any surge is taken up in the tanks. But we're not we're not designing barges large enough to go up to Humboldt and receive 24,000 tons. That's a different problem to tackle. So to do it, you need the capability to treat and store simultaneously for those big discharges. Now, it may be a different scenario for smaller discharges in San Diego, but one thing I want to say about that is that, and it may be manageable, but if a barge were to be towed to San Diego Bay to take up 6,000 tons, let's say, and then back to LALB for treatment, well, then you have to take one of the treatment barges out of service in LALB to process that water. But like I say, it could be manageable. You could do it between jobs or off-peak hours.
I think what I'd like to suggest is that we take a break right now. We're supposed to break at 11. It's 11:06 according to my watch. So if we could be back, because I think we need to continue this discussion. So if we could be back at no later than 11:20, then we have 10 minutes. Then we have half an hour for public comments. And if there are no public comments, I guess we could go ahead with panel comments, if that's acceptable.
We'll have the panel comments first,
Yeah,
and then we'll have the public comments.
but if there's no public comments, we could go back to having,
Continue the
right,
discussion.
or go to lunch early. Thank you. Okay, I think we'd like to get back in order. Okay, so Steve's got some more questions on barge costs, and then we're going to transition to Christine on some data issues. And then at 11:30, we're going to then have some, so that's only like 11 minutes, 9 minutes, and then we have some potential public comments, and then we'll adjourn if we're at 12 o'clock for lunch. Steve?
Before Steve starts, I just want to remind everyone that there's a bunch of blue cards here. If anybody wants to make a comment, please fill one of those cards. Thank you.
Thank you. It occurred to me that it might be nice in terms of the final reports to include in there some discussion of the analysis of peak barge water treatment demand, the process, because it sounds like you went through a process to really give that consideration. At least in reading the documents, it looked as if the number of barges was based in part on 2011 through 15 discharge data, and just putting on my economist hat, it seems like that's the recession recovery period, and I'm wondering if when we look down the road 5, 10 years, when we really get this implemented, what we anticipate future ballast water treatment demand might look like. So that's one. I have one more as a follow-up. Sure, I'll hit that now. Again, being an economist and not an engineer, I don't know the answer to this, and it may be kind of a silly question, but is the treatment that's anticipated on the barges, is it sensitive to whether the vessels have already undertaken shipboard treatment or not? And again, I just don't know. Thank you.
Yeah, I'll try taking the first one. Is that better? I'll try taking the first one. You're right, as we expect economies to grow, we expect commerce and traffic to continue. We're all just at the Port of Stockton, and how interesting and how great that the Port of Stockton saying they still have 10% availability and they expect to be at 100% within the next 5 years. So that's definitely a trend that would increase both the frequency and the volume of ballast water discharges. At the same time, we've seen the container ship industry, in particular, over the last 10 years, significantly reduce the frequency and volume of ballast water discharges that are taking place. We also see quite a movement in many vessel types to reduce their dependency on ballast water, with lots of them trying to eliminate that. So we are using a static number, like you noted, the 2010 to 2015, and doing these calculations. So it's possible that we would need to, with this sort of barge network, increase the number of barges should the rate of increase in frequency and volumes outpace the decreases from vessel designs and more better practices to reduce. And maybe, Jean, any thoughts on the treatment process in the case that a vessel had already started a ballast water treatment using shipboard equipment and now arrives at California?
Maybe I need some clarification on the question. I don't understand that they've done shipboard treatment before and then arriving in California. Could you restate
Certainly. So it sounds as if IMO or Coast Guard is going to be requiring shipboard treatment, and Kevin's really nice diagrammatic treatment or discussion of that it's a much lower level of treatment intensity than what California is going to require. But looking into the future, if a ship has shipboard treatment and has done the Coast Guard required treatment and it comes to California, does that change the nature or the cost or the time required for the additional treatment required to meet California standards?
Okay, I'm sorry I didn't catch it first time around. It could have an impact on the disinfectant dose that's used, because your inflow going in would be at lower concentration, so your effective log removal of contaminants would be less. But I think the important thing is that it would not impact the efficacy of treatment, and you would, if it was designed to meet the guidelines, the California guidelines, it would still be able to do that. And then whether that reduction in cost could be seen real time is a question that we haven't really given a lot of thought to yet, because you'd need to know starting concentration to get to the ending concentration. So that's something that could be explored, and there's an opportunity there. Definitely, thinking about UV dose or chlorine dose, you could definitely reduce, because your CT, your contact time, and your disinfectant concentration could be reduced to meet your log removal rates. But again, knowing what you're starting with after that treatment, assumptions could be made, but I think you'd want to be safe to make sure you meet the California guidelines.
Thank you.
I'll add just a little bit there on, like John's saying, maybe the operational cost, the amount of power, the amount of flocculant aspects like that could be reduced. But I think you'd still want to design the system assuming that the water wasn't already treated. If you're trying to set up a network that's highly reliable and you're expecting shipboard systems, shipboard ballast water to come in at a pre-treated quality, it'll reduce your reliability on what you're expecting to be discharged in California. So I think you would need to design it assuming that the water hasn't been treated and you're taking it from challenged water conditions, even though in some cases it might be less challenging because they've already treated the water with shipboard equipment.
Well, that makes sense. That's the difference between a design approach versus actual operations. Yeah, thank you.
And Kevin, just a quick follow-up on that. I completely agree, unless you could guarantee that 100% of the ballast water coming into California had been treated to international standards before, and then you would obviously have a very different treatment system. Or not different, I'm sorry, you would have a less robust treatment system to handle that concentration.
That being noted,
Okay.
that would constitute requiring ship operators to treat their ballast water twice, right? And so from a ship operator perspective, why do I want to pay additional fuel and power to treat through my treatment system when I could bypass it and go direct to the barge? If I'm paying for the barge, why do I also have to pay that cost? It's just something to think about.
I'd like a little follow-up discussion on that, and I know we've got to watch our time, but it would be very helpful to work through those scenarios and make them transparent to us, because it seems like you've done a lot of the calculations, but we can't read them, and so we ask these questions. The other thing is that you do understand that the IMO regulations are going into place, and 2020 is not very far away. And so I think that's very relative and germane to at minimum operating costs, but perhaps even in looking at the size of treatments and so forth. The other thing that you gave us a picture of the Dahmen system that is clearly available now, and so my question is to consider in this evaluation where there may be land-based or barge-based thoughts and considerations for treatments elsewhere in the world that would help to provide everyone an idea of whether this is a direction that globally may be approached to assure the flexibility of treatment. So are there fittings that are universal, that may be for these kind of modular things? I think, and following up on also in the IMO and regs, and you've clearly made it to us that the transit and the information of who comes into California ports is a diverse fleet, but if they are required with IMO regs to have a treatment facility to go up to Washington or to go to Mexico, I think this needs to be part of the evaluation to at least give some transparency to some of those decision points. And then the final point is just sort of working off of what Steve said, the consistency of reporting data from a time period that ends in 2015. And there was a mention of 2016, 2017, and I think one of the things Kevin was talking about. But we have urged you repeatedly to look futuring in all of these events, as particularly in light of the fact that we have a planned rollout of this for significant amount of time. And so we need trend data, we need, crystal balls. They're never perfect, but you did make assumptions in terms of inflation rates and things like that. So I think to help California understand this, we've got to be a little more futuristic in that.
Okay, I think we better shut off right now for this, and we'll go to the public comments. I think George is going to deal with that.
Thank you, Bill. I want to just remind everyone that we want to keep the public comments short for now. You're always welcome to follow up with written comments to us later. So we want to first call upon John Burge.
Thank you, George. Panel, my name is John Berg, and I'm a vice president with the Pacific Merchant Shipping Association. We represent cargo carriers, dry cargo carriers servicing California ports, and actually ports up and down the West Coast. We've been following this process for a while here, and I'd like to first start by saying that we're pleased that the report that we've seen to date is fairly comprehensive. We appreciate the fact that there's been a lot of effort to address all of the points laid out in the RFP. And it gives us something solid to start talking about here. That being said, we believe there are a couple issues that should be further looked at. And one issue in particular we have some concerns with in terms of the assumptions and findings. Firstly, I think the most important one is actually meeting the California standard. The study makes the assumption that this particular barge system will meet the California standard. I don't doubt that it will probably be better than systems on board ships that are meeting the Coast Guard EPA D2 standard, but as far as whether it actually meets a California standard, I think that is yet to be determined. And I think before moving forward, there has to be a substantive, definitive determination on that matter. Right now, the Coast Guard type approval process for shipboard systems is the most robust testing and verification protocol in the world. And we've now seen, I believe, 6 systems that have been approved for that. It does require significant testing of large volumes of water, and it should be noted that that particular protocol is geared towards a standard that's up to 1,000 times less stringent than the California standard. Nonetheless, we think it's probably a good guideline to say that if the Coast Guard and the EPA were to adopt the California standard, would they be able to give type approval to these barge systems to meet that standard under the system they do now for the D2 standard? That would entail developing new protocols, substantially larger volumes of discharge to sample and test, but we think nonetheless it's really important that we're comparing apples and apples if we're looking at what the ship can do on board versus what can be done by these barges, so that California really has a good determination that the treatment system is actually meeting the standard. The second issue I want to point out to is in regards to the implementation schedule. Under the current legal system here in California, the California standard is in abeyance at least until 2020 due to the fact that best available technology has been determined not to meet that standard. Therefore, essentially, ships are operating, as far as California is concerned, they're operating under the exchange process, but as far as the federal government is concerned, they're operating under the Coast Guard ballast water rule and the EPA VG Vessel General Permit. Because of that, ships don't have to meet the California standard. And once California determines that that standard can be met, all discharges will have to meet that standard. Essentially what I'm trying to get at is there's no phase-in period allowed under this regime. Essentially what we're going to have is literally all the barges in place and all the ships retrofitted or outfitted to discharge to these barges before California can essentially say, we are now going to enforce that standard, because the other existing technology does not meet the California standard. So that means you're going to have to basically forecast how far down the road it's going to be until that situation can be in place. And furthermore, in the interim period, there would be no incentive for a vessel to use the barge system rather than using a shipboard treatment system, because there would be no legal paradigm that they would have to meet. So that's a conundrum, I think, that needs to be addressed, and at least I think it's important for the State Lands Commission and the legislature to understand that in terms of when they would be contemplating making the California standard enforceable. And the last item is the cost implications. The study does extensive work looking at a per unit of cargo basis for determining market implications in terms of competitiveness, cost to the carrier, et cetera. But it's important to know that there are primarily two costs when a shipping company looks at coming into a port. There are the cargo costs, but those are costs that are actually assessed against the cargo and are really applicable to a per unit basis cost. And then there are port costs, essentially what it takes to bring that ship in and do some of the sundry items that aren't directly related to a particular unit of cargo. This particular cost would really fall under the port cost category. And I know you estimated about $38,000 to $118,000 in a per discharge cost. That would be the cost that a shipping company would look at in terms of determining whether they can afford to call this particular port in California. When you look at the fact that existing port calls costs for ships, which vary based on size, are anywhere from about maybe $25,000 to $50,000, you're essentially looking at doubling, if not quadrupling or quintupling, that particular cost under this particular proposal. And that's very substantial in terms of deciding which port to call to handle that cargo. I did submit written comments, which are a little more extensive, to the Delta Stewardship Council yesterday. I have a few written copies here that I can leave for the panel. But anyway, I appreciate the opportunity to provide comment and look forward to further discussion. Thank you.
Next, I want to call on Andrew Cohen. And just as a courtesy, please keep your comments brief, and you're always welcome to give us written comments. Thank you.
Thank you. My name's Andrew Cohen. I'm the director of the Center for Research on Aquatic Bioinvasions. I've been working on biological invasions in ballast water for about 25 years. We publish reports and peer-reviewed papers. A paper we published in Science about invasions in the San Francisco Bay and Delta led the California legislature to take up the issue and adopt a ballast water law in 1999 that I helped to write. In 2005, I served on the task force that wrote the ballast water regulations. I'm here today to talk to you about a difficult topic, which is conflict of interest. Conflict of interest is an ingrained concern in science. It's widely recognized that certain individuals, such as a thesis advisor, can't sit as a peer reviewer of one of their advisees' papers. This is because of the relationship. It has nothing to do with whether the the thesis advisor is a good scientist or a bad scientist or a person of integrity or not. It's simply a matter that certain kinds of relationships, business or personal, certain kinds of activities can lead to conflicts with regard to performing certain services. We also know that scientists have a responsibility to disclose their conflicts of interest. In that case of a thesis advisor asked to do a peer review, they have to say, oh, I can't do that. I'm the thesis advisor of this author. That's expected of them as a scientist. In this particular case, we have a study which was designed to develop information for the state of California in order to look at and compare the ability and costs of meeting California's ballast water discharge standards with shipboard treatment of ballast water versus meeting it with shore-based treatment of ballast water, the emphasis being on the shore-based part of the study because little work had been done on that. In such a situation, it is a conflict of interest to have someone who is involved in the shipboard treatment industry, building treatment systems, servicing that industry, or on the other hand, someone who is involved in the shore-based treatment industry, if any such thing existed, to be in charge of doing the study, to actually do the study from which the state would make its assessments. Because of that, the RFP includes specific provisions prohibiting that. The RFP stated that the award of the contract would not be given to firms that were involved in the development, excuse me, I'm trying to remember these words, the manufacture, development, treatment, or sales of ballast water treatment systems, not allowed to be involved in the development, manufacture, treatment, or sales of ballast water treatment systems. And it required those conflicts and any other conflicts to be disclosed in the written bid document. In the case of the bid here and the event here, the winning team had those types of conflicts, extensive types of conflicts, and did not disclose them in the bid document. And there was a major controversy about this at the time when it happened. I understand that some environmental groups are writing to you about this issue. They wrote about this back in 2014. I don't know if you've received any of those letters. If I may continue. The conflicts involved in this case are that Gloston, the lead company, is involved, has, with partners in the industry, been involved in the development and sales of modular ballast water treatment systems. Gloston, led by Kevin Reynolds, built a ballast water treatment facility, the Golden Bear facility in California, which provides testing services to the manufacturers of ballast water treatment systems. Kevin Reynolds has served on the management of that facility as a naval architect. Nick Reynolds, one of the key, Nick Welshmeyer, one of the key subcontractors here, has been the lead scientist in that facility, has directly overseen testing there, has done testing otherwise outside of that. There are several other conflicts of interest where these companies and individuals are involved in the shipboard ballast water treatment system. None of this was disclosed in the application. We brought this to the attention of the Delta Stewardship Council in protest. They decided they were going to award the contract anyway. We proceeded to file a bid protest under the rules that were in the RFP, which said we should file it with the Department of General Services. The Delta Stewardship blocked that, arguing that they have an exemption from any review of their decisions about contracts. Environmental groups at that point wrote them, urging them to allow the hearing to go forward to determine if there were conflicts of interest. They wouldn't allow it. We went to court to try and get an injunction to stop the start of the study so we could have the courts decide whether the hearing should go forward. Again, the Delta Stewardship Council went into court and blocked that. And they awarded this contract, and now it's 3 years later. So here we are, notwithstanding whatever reasons the Delta Stewardship Council had for proceeding as it did, however it chose to discharge its responsibilities as a public institution, there is a question of scientific integrity that is wrapped up in conflicts of interest. And if this issue has not been brought to you before, it is an issue that I urge you to take a close look at. As far as we can see, the conflicts of interest and the failure to disclose those conflicts of interest by the people conducting the study mean that no one can trust the end results of the study. I know you've been diligently working through several meetings now and reading many materials to try and review this, but I think you recognize that will recognize that on a study this complicated, with this many assumptions behind it, some of which you I've heard today that it's hard to ferret out, and I've been hard put to find them as I look at the materials, with so much behind the numbers that you're ultimately given, that the public is ultimately given, that we have trouble seeing where they came from because the information isn't all there. And even if it were there are judgment calls that on any study like this that are made by the people doing it, assessments about what kind of data to bring in, what kind of modeling to do, what kind of assumptions to make in doing it. And if we start off with a group that has conflicts of interest, that has failed to disclose those conflicts of interest, despite direct requirements that they do so, we end up in a place where no one can really trust the study that comes out. That would be an unfortunate thing if this were to go forward. As I said, this is an uncomfortable topic. It's hard for me to talk about it. I'm sure it's hard to hear someone tell you that we think you need to deal with this issue. But I do think it's your responsibility ultimately to make an assessment of whether the scientific integrity of the study is compromised, to make an assessment whether conflicts of interest have compromised the scientific integrity of the study, and to deal with that accordingly. If you have any questions, I'd be happy to answer them, but that's really all I had to say.
We have another 10 minutes, having seen no other blue cards. Does the panel, any other study-related questions to the group here?
If I can just say, I haven't got it prepared, but I will send you a letter with the main documentation of the conflicts of interest and the main points summarized. So you can have that before you if you will consider it. Thank you.
It's
So this officially, let me just mention. So this officially closes the public comment section, and we're now going to go back to questions from the panel.
Hi, team. I find the public-private partnership model really interesting, and I could see the logic of it. And it seems that one of the consequences of awarding working out a licensing arrangement would be that you would have to have an accompanying process at the state level to review and set rates. And I'm wondering to what extent you've given thought to the cost footprint associated with regulatory apparatus to set and review rates over time. It's one thing, to have a one-time rate that's based on a review of costs, but over time, if you retain that model, then you're going to have something like a Public Utilities Commission type apparatus. And so I was interested in your thoughts on that. Thank you.
Yeah, I'll take the first part of that, and quite simply, we did not build into the cost model a governance piece where, like a public utility, the private operator would say, hey, I know we have this tariff list and it's not really working out. The prices are running away from us. We need to do an increase. So that governance in that process is not included in the cost. Those costs that we're looking at don't include a profit for the private company, and they don't include the public-private governance piece there.
Okay, it might make sense to make note of that in the final report. Thank you.
Definitely, sure.
This is a short comment, again, to look at the costs of the effluent that was referred to in terms of the emissions from treatments and barge traffic related to the treatment barges. I know you gave us a couple of sentences about that you didn't consider LNG and some other options. And to go back, it seemed like I'm just harping on the future approach to how we're trying to control CO2 emissions internationally, the use of particular other options, batteries. I know the Norwegians and folks up there are looking at a lot of different sources for energy, and to completely say that you're not going to cover any of those in the reporting, I think that's needed. It's very important in understanding the regulatory community as well as the future of shipping.
I mean, just a short comment there is absolutely the marine industry, as you're bringing new vessels or tugs, new marine engines on board are meeting, right now we're at a Tier 4 treatment standard according to EPA for marine engines within harbor complexes in California, in addition to various clean fuels. So that's what's required, and that's the cost basis for what's there. We'd be very happy to look at, there's many projects that are using natural gas and fuel cells. There's even abilities in some cases to plug in charged batteries and get certain amounts of operational time in. Those do come at a additional capital and operating expense and even maintenance and repair. And we can definitely look at those. And although I think that those would increase capital expenses, and like you note though, it would reduce air emissions. So we'll perhaps have the dialogue with the panel as to what we should set for the assumptions and what we should, what sort of sensitivities in terms of different costing we should incorporate.
I think what we'll do now is break for lunch. It's 5 minutes to 12, and we're supposed to be back here at 1 o'clock to continue the presentations by Gostin from 1 to 1:45, and any comments then from the peer review panel. And we do have one last, then the peer review panel and presentations, and then from 3:15 to 3:30, if there are any additional public comments, we'll take those at that time. So George has got something to say.
Just one quick comment before we break for lunch. The Delta Science Program's procedure for conducting these independent studies do require that we maintain transparency, so all comments are, to either the panel or the study team should be coming through us first, and we make it available to them and to the public. Just a quick reminder. We'll meet back here again at 1 o'clock after lunch.
I think I'm going to repeat it here.
Okay.
Yeah.
Continuation of the presentation from Gloston, and the panel's here, the consulting group is here, and one person in the audience is here. Okay, go ahead. Now, do we have to signal to the guy up there? No, he's got us. Okay.
All right. I hope lunch was good. Let's, we've got, what is it, Peter? 5 or 4, 5 presentations to cover this afternoon. And to me, I am really excited to get to the question and answer and have the dialogue with the panel. So let's try to lay the foundations here. So have the slides up here. So right here, we're looking at the Port of Long Beach. This discussion is going to be about outfalls. So as we look at Long Beach and we're just kind of staring around there, I see a lot of ships and I see some barges, I see a lot of empty docks. So from the perspective of outfalls, it's like, where are the outfalls for ballast water discharges? In no real scientific manner, I threw up some yellow arrows. Those would be outfall locations on whatever day Bruce Perry from CSU Long Beach was able to take this photograph. So on this particular day, I count a potential, about a dozen outfall locations. From the data that we studied, looking at frequency distribution, it's pretty unusual to get more than, I think it was 3 or 4 ballast water discharges at the same time in the port of LA Long Beach. So of these, maybe 3 or 4 of them might be discharging ballast water at a time. From a perspective of outfalls, how does that relate to mixing? Are we talking about 3 all right next to each other, or are we talking about 3 or 4 that are quite spread out? So just a little perspective from ships. We also look at current practices. What do ships' outfalls look like? So if you recall, at workshop 2, we went to SA Recycling, and I was so happy because at that spot, they had that ship that's on the top left picture there, that left side picture, and it was discharging out of its sea chest. So if you recall, the water was just kind of welling up all around the stern of the vessel. So that outfall would be heading straight down. Possibly it was welling up so aggressively like that because maybe the water inside the ship was a little bit warmer, so it was buoyant. If we look at top right, there's a tank ship with a very typical ballast water overboard pipe right at what we call the water line. And in this case, it's a plunging discharge that'll have a certain characteristics of local mixing. In the bottom right, that ship's actually underway. It's, don't get confused, those front 2 discharges are actually to clean and lubricate the anchor chain. So that's not ballast water. The 4 on the starboard side there, a little bit aft, those are ballast water discharges from individual tanks. So the real point here is when we talk about outfalls from a ship, the variety is incredible, just in what it might actually look like. So when we think about if we implemented treatment barges, what would the outfalls look like? So very simple diagram here, just saying on the left, there's a marine vessel, there's the ship, and it's just pumping the ballast water into the harbor. There may or may not be currently treatment efforts that are going on inside the hull. They almost always will have at least performed a ballast water exchange. So that would be deep oceanic, rather salty water, maybe 32 PSU, practical salinity units in that range. And it goes into the harbor by any of those under the water, above the water discharges. If we look at the outfall with the treatment barge, we're transferring it to the treatment barge. Each of these treatment barges do have a surge capacity as conceived. So they would maybe have an hour to 4 hours of surge capacity to receive ballast water without discharging. That allows the treatment barge discharge could take place over a longer period of time. In other words, collect the water over 10 hours and discharge it over 14 hours. But essentially, it's the same water that then gets discharged after organisms are inactivated and particulates are removed. So that introduces another waste stream, which would be those solids or the slurry that goes to a landfill. So this morning we talked a little bit about what could we do in San Diego, and we can absolutely explore reception only in San Diego without treatment or discharge. For the most part, these ballast volumes are too large to simply capture and do the outfall in another location. I would say, just hazard a guess that it's 80% of the discharges would have to be treated in place. So the outfall location would be, 80 feet to the left or to the right of where it would be as when considered business as usual. So again, on this concept for what would a treatment barge look like, there is some flexibility for what that outfall would be. There's studies can be done that could consider, do you do the outfall below the vessel? Do you do it as a plunge? Do you do it in several pipes so that way it's distributed so you encourage mixing? Those are all things that are practical to do that in the study of the outfalls for these barges could be explored. There's ways to encourage mixing to reduce what maybe a salinity gradient might look like at that location. Here, giving the discharge rates. So for the small barge, for example, we're looking at the ability to store perhaps 2,700 tons of ballast water, which we would then discharge at about 700 cubic meters per hour. Large barge, perhaps 10,000 tons of ballast water storage capacity, which would give us that surge volume, and then discharging at about 2,500 cubic meters per hour coming from that barge. The slurry for the small barge, we're looking about 2 metric tons of slurry volume capacity that we'd need to capture, which is certainly less than a truck. So you could probably do a good 10 loads before you end up with a truckload of sludge that would have to be taken to a treatment plant. Large barge, quite a bit more, maybe talking 7 tons after it did a single treatment. So let's look at zone 5. So zone 5, for a moment, if we treated 5 million metric tons of ballast water, we'd be looking at about 1,000 metric tons of slurry that would be captured. That's about 72 trucks in the Zone 5 location that would need to transfer that sludge to landfills at a cost around $400,000. And that's tabulated for each of the additional vessels, about $1 million per year and about 170 truck trips to capture that sludge from this treatment plant process statewide each year. In terms of outfalls, we'll see a little bit more information in terms of regulatory permitting, but this would be part of the National Pollution Discharge Elimination System process administered by California Water Board. And they will require a pre-permit study and then permit monitoring and reporting. We'd estimate 2 to 3 years for that. And some initial discussions with the Water Board indicates that it might be possible to get a general permit that would cover these 24 barges in all 6 of the zones. Definitely a significant effort to go through that process. The things that could be affected might be the outfall. Just simply, do you specially design the way these overboards are to encourage localized mixing? A big challenge here is total dissolved solids. And we'll talk about a little bit more in a few slides here, but It's with the footprint allocated and with the size of the barges here, we're able to meet the California, at least on paper, we can meet the California discharge standards. There is not enough room practically to do a desalination plant, for example, with these barges. We're at about 6 times the power and about 20 times the footprint for equipment that meets the California discharge standard as compared to the federal and international standards. To do a desalination plant will require many times that footprint and power, and we just get into a place that's impractical. So TDS is something that is not practical to control with these processes. A concern is the marine vessels themselves. Now that we collect this water and it becomes industrial wastewater rather than ballast water, and we look at NPDES permit requirements, there's a potential that the different anodes that are used inside the ship's ballast water tanks, the sounding tubes, the paint, the rust, the scale, could result in contamination levels that we just don't see. It's not that they're going to be newly introduced compared to business as usual, but it's that we're going to have a tighter lens on it, and it's something that we're going to be able to actually recognize. The treatment process in the treatment barge can remove the particulate portion of those contaminants, but items that are dissolved are probably not practical to remove. So it does give the water board a very interesting question, which is, we can clean up to some extent this waste stream that's existing, but maybe not to the full extent of the requirements. Can we permit this? There's another piece here too. You need to consider that these ships are traveling from many different states and many different countries, worldwide trade. Are there contaminants from the uptake source? For example, is there a river system that maybe has dioxin? And that's a chemical that's going to be very difficult to remove with a treatment train, and it's not designed into this. What would be the requirements for monitoring for those contaminants, and what would be the requirements if we saw those contaminants? So key findings from the outfalls are the treatment barges wouldn't significantly change the locations, the volumes, or the makeup of the current discharges. They would significantly reduce the organism loads and the particulate matter. However, we're probably going to have significantly better vision into other contaminants that are in those current outstreams, and it's going to be a challenge to us to wonder, what do we do about that now that we know it? Okay, next presentation. Thank you, Peter. I'll be sure to end that streak. So now let's talk about permitting and legal. So we looked at the different authorities, and I think this is comprehensive. U.S. and it's just, what would they think about a treatment barge? And U.S. Coast Guard and IMO both have significant language that talks about treatment facilities, and in some cases, in particular for a Coast Guard, they address treatment barges as onshore opportunities. In Coast Guard's view, once it leaves the ship and it goes to any reception facility, barge, ship, land-based piping, it's no longer a Coast Guard regulated discharge, but it must, in Coast Guard's view, follow the NPDES process. State Lands Commission, their communications with their teams indicated that just because it transfers to an alternate path doesn't mean that you're relieved from meeting the California interim standard. In other words, you can't say, it's no longer ballast water. Let's just make sure that it meets the current requirements that are silent on aquatic invasive species. So that's not allowed. EPA has specific language that discusses that each treatment barge will require an NPDES permit. And State Water Board becomes, in this case, the important authority in that they would be issuing the permit and potentially requiring the studies and potentially issuing the general permit across the different barges. Little word on IMO. So IMO, it actually entered into force. So the IMO convention was adopted in 2004, and it was ratified about a year ago, and it actually entered into force. So it's currently in force as of 8th of September 2017. The regulation B3, Part 6, exempts vessels that discharge to ballast water reception facilities. And G5 is actually an entire guideline written as part of the IMO process that specifically talks about ballast water reception. So there is a framework within the international community for transferring ballast water from ship to reception facility, whether it's another vessel or it's actually land-based. A quick aside there, there's also an ongoing effort today at ISO, International Standards Organization, for what such a standardized connection might look like. And I think Audrey brought up the point about the Damen barge being in existence there. Oh, sorry, it was Christine. And yes, indeed. So they are trialing. They're doing what I think this would require, which is a prototype trials and demonstrations and efforts to prove that process and those sort of connections. So that's certainly not widespread. I'd be guessing that it's 4 or 5 vessels that have such a connection out of the 40, 50,000 ships, but it's the proper way to go is to do those sort of trials. So it's very nascent, very, very new. U.S. Coast Guard in the 33 CFR 151 specifically addresses transfers from ships to reception facilities, and they give some guidance there. Namely, as was highlighted, it goes to the NPDES process. State Lands Commission, their Marine Invasive Species Act requires that they would approve any reception facility. So the good news is that there's in the current rules, there's a path. It was mentioned, I think John Berg from Pacific Merchant Shipping Association in his public comments mentioned that the way the California rules are is that it just kind of turns on like a light switch in, I believe it's January 1st, 2020, to require meeting the ballast water standards. And so that's something I think that there's maybe a gap between the regulations and practical implementation that would need to be addressed. It's not such a great idea to require 1,500 ships starting on one specific day to start offloading all of their ballast water immediately. This idea of building 24 barges that haven't been extensively trialed and ramped up, and then a ship transfers is probably a bad way to do it. So to look at the regulations and understand, are there some needed changes there in way of State Lands Commission's rules should be discussed. Perhaps that's something we can pick up in the report. US EPA, again, they're quite specific about the treatment barge and what the rules are in transferring ballast water to specifically a treatment barge. And again, California Water Board will be absolutely the central authority here if this path is selected in evaluating. Back to the question of how do we deal with now knowing more when we compare planned activities and planned discharges with what current practice is. If we look at ship discharges, accordance to the vessel general permit, so this is, some ships are in fact treating with ballast water treatment systems and the remainder doing ballast water exchange, and the EPA vessel general permit covers this today. In terms of biological efficacy, it's their efficacy in accordance to the VGP is not as high as compared to a treatment barge. in terms of water quality, they do discharge these high total dissolved solids levels, in other words, salty water into local freshwaters. As far as, so the question is, if we do business as currently planned, the ships meet the current requirements, and that TDS is high. If we do ship discharges to barges with no total dissolved solids, we would remove significantly more organisms, and we would remove the particulates, but there would be no significant change to the TDS or salinity. So you're left with that question of, should you implement this and recognize that we're going to continue to put salty water into freshwater ecosystems? Is that net good or net improvement allowable? Or would we say that because it's not practical to remove the TDS, that it shouldn't move ahead and do these salty discharges into freshwater systems? If we looked at the ship discharges to barges, and then you keep the total dissolved solids requirements there, you still would meet the biological efficacy. You would get that great boost in efficacy, so many fewer organisms discharged. But we'd have to receive 100% of the ballast water and then barge it away. It would probably triple the cost for these locations. So we don't have the calculations, but if we said it was $120,000 for a ship to be serviced in Stockton, where we're not impacting the total dissolved solids, maybe we're somewhere in the range of now $300,000. So that's some definite consideration. Back on, so on legal, probably the big legal question that we have is, how does the state implement this in a way that doesn't trigger essentially lawsuits like Washington State saw when they tried implementing emergency tow packages on the bottom right there. So actually, I was working on tankers in early 1990s. We outfitted a whole bunch of our ships with these emergency tow packages. It wasn't such a huge deal. It was probably similar to, for us at the time, to doing these ballast water transfer stations. And then Intertanko, on behalf of the tank vessels, sued the state of Washington and lost. The regional court said, no, you're protecting these pristine waters. This is worthwhile to do. And then the U.S. took over from Intertanko and brought it all the way to the Supreme Court in the state of Washington. Gary Locke lost the case, and the case was decided on because the federal government had been actively pursuing, mostly from the Oil Pollution Act of 1990, the design and the design of vessels to reduce the risk of oil spills from vessels. The states couldn't go to an area where the federal government was already engaged. In other words, the federal government had preempted the states from that area. So the question here for California will be, how do you implement a barge-based or land-based? It would be the same issue. How do you implement a shore network that requires a connection of the ballast water to these shore treatments without kind of getting fouled up into preemption discussions? Likely the answer is by requiring the treatment standard, but not the, requiring the requirement, but not the cure. Not saying you need you need to put in a transfer station to these specific dimensions, or even saying that you need a transfer station. So it's a little tricky, and it does introduce significant risk to implementing this network. So imagine, as we think about commercializing or this public-private partnership, dear partner, we want you to invest and we want you to spend time and effort on this, but we really can't tell the ships you have to install the connection that you need. All we can tell them is you're not allowed to discharge unless you meet the standard, and oh, by the way, there's this public-private partnership that has a series of barges that are able to meet the standard, and if you install such a treatment, such a transfer station, then you have a chance of meeting the standard. So a couple other short notes are, when we transfer this water, there is a transfer of liability. So are there handling the hose? That's something we're used to in the marine industry. Explosive gases, will the ballast water have explosive gases, oil leaks? Or what if it's coming from an area or location where the water is in fact contaminated? Reception of other effluents. Just in this right here is a long listing of the incidental discharges that the EPA Vessel General Permit covers. The quite applicable ones would be deck runoff. You have rain that gets small amounts of oil or paint chips and the like on the deck. Oily water from the bilges, gray and black water. For the most part, with the exception of the deck runoff, vessels are able to manage those discharges without, faster? Okay, without actually discharging them into state waters. In either case, these are small volumes in comparison to what the ballast water is. So I would say it's quite practical to have multiple purposes for these vessels. But please recall that it's only about 1 in 4 of the vessels calling in California that need the treatment barge. So only 1 in 4 would have easy access to the treatment barge for these services. So if you really wanted all vessels to have such a treatment barge, you probably don't quadruple the number to service all calls, because you could probably do these sort of services with much less expensive vessel. So in summary, the international, federal, and state requirements, they're set up today for such a network, quite explicitly in many cases in way of a treatment barge. The ruling regulation then will be getting this permitted under NPDES. Total dissolved solids, salty waters, that's the main sticky point for that permit. So a lot of that introduces some risk. We're now going to start building barges while we go through the permitting process, or do we slow down and delay until that issue is fully resolved and then start building the barge network? Implementation will need to be indirect. I don't think the state, it's going to be risky. It would be risky for the state to straight out require ships planning to discharge ballast in California must install this equipment. It probably needs to be indirect. Chain of custody in terms of different pollution concerns, and also is going to be important, but that's a knowable path. Expansion to other effluents is feasible, but keep in mind that we're only servicing with such a barge network about 1/4 of the vessels. Okay, so this piece is talking about comparison of shipboard treatment to shore-based treatment, and definitely over lunch and otherwise been thinking a lot about, should we do this just as storage barges in the case of San Diego? Also thinking over lunch and actually all along that in some cases, in some locations, as you dig into the design work, as it's really the rubber hits the road, there are going to be places where the pipeline makes some sense. So this barge-based network is really presented as a knowable global solution, and it gives us a cost that we can be comfortable with. As we get to the real nitty-gritty specifics, it will always be some sort of a hybrid where some locations would be piping networks, but I think that at least the 80%, if not the 90% answer in this case is going to be the barge-based service network. So bear with me as I really do continue to focus on that solution. So we're looking here at a tractor tug. It's actually built at a shipyard I used to work at. If you look at the little, right in front of the word tractor tug, there's like these 3 little pipes that make a goose bend. I designed that. It's a pretty small accomplishment. If I recall, I think these are Tier 2 engines on this tractor tug. I don't think that they've done any upgrades since we delivered it. Oh, it must have been 1999. It's quite a nice boat. But I think you can see the smoke coming out of the stack, and I think tells most of the picture. It's when we go to do this network, we're going to be pushing around a ton of gear. And as we push around that ton of gear, there's pollution. And it results in some congestion. So if we're at a not so busy port, is one more tugboat cruising along, pushing a barge going to cause any trouble? No. If we're in a real busy section and things are kind of tight, we had a great conversation. We were at Port of Stockton with the port commissioner and the operations director. And they said, yeah, we used to never worry about logistics. We always had extra space. Yeah, sure, just tell the ship, just come in whenever you want. But now they have to consider things a little bit more carefully. You got to wait until tomorrow. You can come today. So in Port of Stockton, for example, I think we would definitely be increasing congestion, especially as they go up and reach 100%. In terms of the treatment process itself, we're using 6 times the power as compared to shipboard. So, for example, think a little bit of container ships and cruise ships. They do cold iron currently. So if they were treating their ballast water on discharge, they would be plugged into the grid, where hopefully you hope that the emissions from the grid are in locations away from populations, that they're using the cleanest available power. That's the hope. Then those emissions on an energy basis would be less than the emissions you would get from a treatment barge meeting the requirements, which today would be a Tier 4 engine. Christine's comment is worth note, where could the treatment barge be using really fuel cells is probably the direction that we might consider. And with fuel cells, they would have 0 emissions. But the fuel cells are, frankly, they're not incorporated into the cost. And we could certainly do the turn to look at what would be the cost of the fuel cell power. With something like a 600 kW, it's not that hard to do, Christine, to come up with those costs to limit the emissions. We can do that. Let's see. So, just looking at this one slide, that's the big story there. We're going to get multiples more air emissions doing this process as compared to just doing business as usual. That's the price. The water effluents are going to be obviously much cleaner. We're going to get all that particulate out of the water. We're going to get the biological loading is going to be reduced. I'm just going to flick through these. I think I've covered most of this in that initial discussion there. A lot of this is discussing, really the one is retention. So vessels are already working and have worked for a long time to try to retain their ballast water as compared to being discharged. And obviously, if you're retaining, that's quite helpful. One other piece to recognize is that the discharge of ballast water is only half the equation. As you're taking up ballast water, all these ships are going to be treating on the way in. And in most cases, like electrochlorination systems in particular, your biggest energy draw comes on the uptake. So this process would not eliminate that. Let's see. I think really that covers these slides here. This is a nice picture. It shows the large treatment barge, at least a footprint, alongside a vessel at a dock. So there is some restriction there. And I think we saw in Port of Stockton, we were looking at some cases where this one ship was kind of sticking out into the channel.
It is Stockton, actually. That's the East Complex.
Okay, perfect. And you can see that in some cases, having a barge alongside is a challenge, or it can be a problem. So it's not a no impact to logistics. Oh, I think isn't that San Pedro?
Yeah, that's.
Wilmington?
Yeah.
Yeah, so there's Wilmington, and obviously if a ship was trying to get into the berth above that location, there'd be some logistics to take place there. The tug would probably need to move the barge out of the way, put the other ship in the location, and then they'd be able to berth it and then have to bring the tug back. So these are all solvable things, but yeah, you're going to increase port congestion. So again, the barge effluents significantly cleaner. Going to shore-based treatment does increase emissions by at least 6 times, plus the effort to move the barges around by the tug traffic. And it would increase port congestion in way of places that are already busy. Thanks. I do apologize. It's almost impossible to look up in that direction or down there and see the slides. Yeah, thanks, Peter.
Thanks, Kevin. I'll try to leave you some time to talk about market impact. But I have to admit, I really enjoyed ripping into this Task 9 scope of work on looking at underway discharges in California. First, I wasn't quite sure what I was getting into, but it turned into be a really fascinating little study. So, okay, so yeah, Task 9 is focused on looking at current underway ballast water discharge practices in California and how might we deal with that. What mechanisms might we be able to employ to minimize or potentially eliminate underway ballast water discharges? So all vessels do this, or all vessel types, but it's a really small percentage of the vessels that are calling California, as you'll see. Why do they do this? The answers are essentially these 4 bullets. They do it for operational convenience reasons. I'll get into some examples. Efficiency purposes, vessel trim, stability, and mitigating hull stresses, bending moment, and for safety and navigation. Sometimes that's to mitigate vessel motions, sometimes it's to reduce air draft, and then later to increase underkeel clearance. So interestingly, the NBIC data doesn't, there's no way to really sift through the NBIC data and say, show me all of the underway discharges in California. The reporting process isn't set up that way, but it does provide the discharge locations. So generally it's, I discharged in Port Hueneme, or I discharged in Humboldt Bay. But sometimes the locations are given as geographic coordinates. And so that was one assumption that we made, is that when it's given as a latitude and longitude, that is potentially an underway discharge. It's important to say here that there's no data on outbound vessels. NBIC data is collected for inbound vessels that are making a California port call. And so their associated ballast water discharges, they're married up with an arrival. And so when ships are on the way out, we don't have any way to capture what they're doing in way of underway discharges. But I think once we dig into the data here a little bit, you'll see that it's very likely a small number of events to be managed. I forgot that I'm managing multiple, my screen and the screen up there. So Here we are. Now we're caught up. So can everybody see that? There's about a zillion yellow specks on in the North Pacific. These are the geographic coordinates of ballast water discharges reported for inbound California vessels, where the location is shown as lat and long. So these are essentially underway discharges. Well, what are they? What are they doing? Most of these, all of these that are occurring outside of the 200 nautical mile boundary of the EEZ are ballast. This is ballast water exchange. Okay, so this is not the same as an underway discharge within California waters. Within the EEZ, what are all these? That's kind of what we needed to get into. So for the purposes of this study, an underway discharge is defined as one that occurs in any location within the U.S. contiguous zone. So basically between the offshore area or anywhere in port out to 24 nautical miles. We can't regulate with the California statute anything beyond 24 nautical miles. So that's the definition here. Anything beyond 24 nautical miles not considered in the study. So taking a closer look at that picture of the North Pacific, kind of zoomed in on California here, you can see if we eliminate and take away anything outside of 24 nautical miles, this is what's left between the years 2011 and 2015. If our assumption's reasonably correct that when they report lat and long that it's an underway discharge, this is how many there were over that 5-year period. Worth noting here too is that some of these events were single vessels discharging multiple tanks and reporting each tank discharge as a separate event. Okay, so how often does it occur in California? 53 times in a 5-year period. 32, these discharges are attributable to 32 unique vessels. That's 11 underway discharges per year on average. The average volume is 700 metric tons, and all 53 were less than 3,000 tons. These are not big volumes. Here it is broken down by vessel type, and it's not super meaningful, but most of this is done by tankers, container ships, interestingly, and bulk carriers. Really all this tells us here is that passenger vessels are not doing this. Okay, in the Task 9 report, I spent a fair bit of time trying to make a clear distinction between what I'm calling an elective discharge and a non-elective discharge. What do I mean by that? Well, what I'm saying essentially is that there are certain circumstances where the ship has some discretion as to when they discharge and where they discharge. And then there are other circumstances where it's hey, we're going to get to a point where we have to deal with this now or we can't proceed. So that's essentially what I'm calling an elective and a non-elective discharge. And I mean, you can read these definitions here. That's kind of what we came up with in the Task 9 report to kind of call them out specifically. There are those that, elective are those that can be avoided, they can be postponed, they can be conducted outside 24 nautical miles, or they can be handled in port in a different way. Non-elective underway discharges are those that are essential for the continued safe operation or navigation of the vessel, the timing of which the crew has limited ability to control. They cannot practically be deferred or conducted in advance of an event or a specific portion of the voyage. Here's some examples of elective underway discharges. Those that would be done for convenience, to trim the vessel for routine cleaning or maintenance or for other operational purposes, or they're conducted for the safe operation of the vessel, but the crew, again, has some control over the timing of the discharge. So an example, hey, we're going to a berth that has a controlling depth of 13 meters, and we're deeper than that right now. Sometime between the middle of the crossing and before we get there, we need to lighten up a bit, right? They've got some discretion as to when they do it. oftentimes the elective discharges are related to reducing time spent at berth, right? So it's about being efficient when you get alongside, so you don't disrupt refinery operations, so that you're not occupying someone else's berth window. Sometimes it's done to simply to reduce crew workload on arrival, so that they're not distracted with multiple operations. And other times it is done to manage rough sea conditions, but again, this can be done proactively. So generally, unless it's an emergency situation, I'd say ballasting, even to mitigate against rough weather, I'd call that an elective discharge. Okay, well, so then what in the world is a non-elective discharge? Almost exclusively, it's about increasing your underkeel clearance for a certain portion of the voyage, or that so you can dock at a berth that has a draft restriction. The only other circumstances when it's a non-elective discharge is when it's an absolute emergency. So conditions, maybe you find yourselves quickly in some quickly deteriorating weather, and you want to take on an additional safety margin. What the current GM is not safe, or the vessel motions are getting to a point where you're increasing the risk to property or to the lives on board. Refloating a vessel after a grounding, that would be a non-elective discharge. Or if you experience some shift in cargo during the transit, you're trying to correct a list that's compromising safety on board. These are emergency discharging. These are extremely rare events. Okay, so this is a photo of what might have been a non-elective discharge. This bridge, this is the Benicia Martinez Bridge, it's quite low, and there are certain vessels that have high air draft, and if they don't, to clear the bridge, right, they may have to take on additional ballast so that they temporarily reduce that air draft height. Then when they get under the bridge, they've got to transit some area with a draft restriction, a controlling depth of, say, 35 feet. Now, okay, we passed under the bridge, now I got to discharge that water that we just took on. That's a non-elective discharge. Okay. So we made a couple important assumptions in the report, and that was, remember those little specks I showed you within the 24 nautical mile zone? What we've assumed there is that anything that occurs within, anything that occurs outside California's protected bays and waterways, so between the outer coast and 24 nautical miles, we're assuming those are elective discharges. So all of those could go away by either dealing with them in port, or vessels can do it either outside on departure or before they enter the contiguous zone on the way in. The transit time to get through that 24 nautical mile area is about, depending on vessel speed, 1.5 to 3 hours. So unless you're in an emergency, you can wait or you can be proactive with this discharge. Now, conversely, anything that we noticed reported inside California's protected bays and waterways, we assume to be a non-elective discharge. So this is all the non-elective discharges in the Northern California area. And if you look at it here, some of them are in the middle of the waterway. Others look like they're potentially reporting inconsistencies in reporting, where they're giving lat and long positions for vessels that are actually at berth. We don't have a way to verify that, but it certainly looks like some percentage of that is what's going on here. So, but anyway, it's very few underway discharges that we're talking about. And here's the picture in Southern California. The yellow trapezoid there in the south is Pacific area lightering. We actually aren't considering those as underway discharges, since the barge network would actually treat that area. They provide regular service to that area. But these others, outside the breakwater, they may very well be. So here are the non-elective discharges in California, underway discharges in California by zone from the years 2011 to 2015. It's 11 in total, most of them in Northern California. So besides the NBIC data, we did have phone conversations with vessel agents tug operators, some marine pilots in the San Francisco Bay Area, and a couple cargo vessel operators. And they corroborated that, yes, this is often generally related to increasing underkeel clearance for transits, say, over Pinole Shoal in in the San Francisco Bay Area, or down into Redwood City, where there's a relatively shallow channel down there. Yeah, and they explain that the bridge thing is an issue, but something that they encounter really pretty infrequently. Okay, so how do we minimize or eliminate this? For both non-elective discharges related to normal vessel operations and any elective discharges that might be conducted in port, the practice of discharging ballast into coastal waters while a vessel is making way can be eliminated by conducting these operations at anchor within California's protected bays or waterways. Here, they can be serviced by shore-based ballast water treatment barges. Emergency deballasting is the only form of discharge that cannot necessarily be avoided or conducted outside 24 nautical miles or deferred until they get into port. And those instances are so rare that beyond being rare, that I don't know how you address those extreme emergency cases. So in the report, we talk about we introduced the concept of a deepwater service station, which is a fancy name for an anchorage. It provides a safe deepwater location where vessels could stop. They need to discharge in port, but they can't do it at the berth, whether it's because they have to clear the berth or whether it's because they can't get to the berth without increasing underkeel clearance. So they can take care of this prior to transiting shoals or other inland waterways, or potentially prior to departure. So these would have to be located within the operating radius of treatment barges within each zone, and it would be essentially equivalent to a bunkering operation at anchor, which looks like this. And that slide I showed you earlier from my Task 13 presentation, same idea. It's an anchored ship, and it's a barge alongside. That's the same procedure that would happen dockside. So these deep water service stations could look like a swing circle, like the anchorages do in the San Pedro Bay area, or they could be general anchorage areas, which are, can be really any shape. So implementing these deep water service stations to deal with the underway discharge issue would introduce scheduled delays, but it'd be for a very small number of vessels. We're talking about 11 per year across the state that even do this, and maybe half of those would opt to, because if you assume some percentage of them are elective discharges, they may opt to not do it in port and do it outside 24 nautical miles. So it might be as few as 6 vessels per year that we're talking about. And those delays would be incurred mainly by ballast-dependent vessels only. Delays might range from 4 to 24 hours, possibly longer, depending on the volume of ballast water that has to be received and treated. So impact support in marine terminal operations. In summary here, no significant impact on port operations is expected. Anchorages within port districts, they might experience a slight increase in vessel activity because of managing these underway discharges. And we expect no significant impact on marine terminal operations either, since vessels could opt to do this either before arrival at the berth or depart the berth and do it at one of the deep water service stations. So this is not what we would experience. I think we'd be talking about a really small impact. Okay, key findings. Majority of underway discharges occur outside the U.S. contiguous zone. Underway discharges in California within 24 nautical miles are infrequent, about 11 per year. Most discharges are elective in nature and can be conducted either outside 24 nautical miles or conducted in port. The deepwater service station concept offers a practical means of eliminating underway discharges in California, and it would likely have no significant impact on port or marine terminal operations. Vessel schedule impacts would occur, but the number of affected vessels is likely to be very few. Thanks.
All right, I'll try to catch us up on time, and at the same time, this is another just absolutely interesting topic, so we'll mine it. So we've seen this slide a few times already. This is the cost slide, and these are numbers that we can build on as we look at market implications. So market implications is the same thing. Is the shipping industry going to go, no way, that cost, I can't bear that, I'm not coming to California? Can the treatment barge operator, is that something that's reliable where they're going to jump in with both feet and line up out the door to start up this network? Would the ship operator, based on a little bit what John Berg was saying, if their perspective is this isn't a cargo additional cost, this is a cost off of my bottom line, what's $30,000 mean to me in a port cost? And I think he gave us part of the answer. Ships are looking at $25,000 as typical import fees that they might be paying. So frankly, these are significant numbers. And lastly, perhaps the most difficult one to put your finger on is what's the cargo shipment impact? And that's where I think this really gets to what's the market impact? Is it going to affect commerce in the state of California? So from a ship operator perspective, if they install the U.S. Coast Guard type approved system, it's $500,000 to $3.5 million. It's very difficult to, those are good rough numbers. As per our Task 2 report, to get that transfer station installed, $150,000 to $300,000. So what's that, 10 to 15%, no, 10 to 30% increase in cost, depending on your scenario. Is that going to cause shippers to say, hey, we're not going to California? Maybe in some cases, probably logistically, if you had some vessels that weren't planning to call to California routinely, and they said, are we going to be California ready? They might opt not to. Does that then decrease the universe of vessels that are qualified to call in California? Sure. Does California already have certain requirements that require vessels to be California ready? You do. So has that pack already winnowed down to some extent? Probably. I hate to not give you really concrete answers. I hope that's helpful. I like this, brought this out as a nice example. If the bulk carrier day rate, right now there's international indexes on what size bulk carrier it costs to hire the ship for a day. Now, mind you, these exclude fuel cost. The way ships are chartered is you negotiate a day rate for any particular term, and then the charterer also pays the fuel cost. And the reason that's done is fuel costs are so volatile that it would be difficult to put into a contract. So bulk carriers today are about $12,000. So those bulk carriers that call up in Stockton, $12,000 a day. You could rent one for a week and have a vacation on it if you wanted to. If we're looking at $120,000 to service that vessel, that's 10 days of operating expenses for that vessel. So with 10 days, could you maybe go through Panama Canal? Could you maybe go to Canada? Could you maybe divert to different locations? And then as a result, would you then need to truck that cargo or train that cargo to another location? I think 10 days is significant. I think it's a big deal. And we put the question, maybe I don't know if the question was well worded, but tried to put the question to Port of Stockton yesterday and said, what would that mean? And I think we just said 100,000 to keep it simple. And anybody recall what the words were? Yeah, but what was their response? I can't remember the words.
Said it was going to be pretty impactful.
Pretty impactful. Yeah. So it's, again, these are hard to quantify, but that's just to get our mindset into that a little bit. Another piece here in terms of market impacts, a very significant concentration of cost. If we're looking at 9,500 annual ship calls in California, there's only 1,500 are associated with ballast water discharges. So we could spread the cost across all ship calls, in other words, sort of like a vessel call fee, But that's a big discussion. Sometimes discouraged to try to, what we're going to discourage all commerce so that the commerce that's actually costing money is not disfavored. Probably the cost gets concentrated on those 1,500 ballast water discharges. Then further, if you look at 5 years, let's see, 1,500 times 5. That's what, 7,500 ballast water discharges are done by 2,300 unique ships. In other words, some might only be done by one ship who never come back, but a lot of them are done by repeat vessels that come again and again and again. So it's more concentrated than it might look. Those 2,300 unique vessels in each 5 years are going to bear the full cost. When we start thinking about what does that mean for commerce, it means that we are, this is typically, not always, but it's typically a cargo export activity. So folks that are importing cargo would be taking ballast water up to offset the weight that they put ashore in California. So those bringing goods from Japan, China, Korea to California, predominantly if it was a net import to California, they're not going to be impacted as much by this sort of cost. It's those agricultural goods, it's goods leaving California that are getting exported out that are going to see the majority of this cost. So that's a high concentration there. The variation of cost is very interesting, and this, again, it's very difficult to put these numbers together, but if we look at, unfortunately, I just lost my screen here, to look over there. If we look at $118,000 for a ship call, and it's divided by 1,400 TEU, that's a very different number than if it was $35,000 for a ship call over 14,000 TEU. That's, can't quite read it, is that $84 per TEU in comparison to $2.55? So what's that, 30 times factor? So very significant differences. So what does that mean? That would mean that the port that has the lower cost perhaps is able to continue to do business, and the port that has the higher cost would lose that business. So you would get a combination of transfer of cargo from within California ports, shifting from outlier port to they would lose their remaining cargo or a significant part of it. Certainly on the export side, that would then shift to a more cost-effective location. So here, looking at cost by cargo for tankers and bulkers, we looked at this already, and we see that for the large ballast-dependent vessels, there's not a whole lot of variation there. So this could be looked at in terms of total cost of shipment. If we look at the cost by container ships, quite similar. We looked at this before as well. This significant variation in cost depending on how many containers you're moving or in terms of what the cost is by port. Same with the car carriers and passenger ships. We looked at these here, and we'll just kind of look at potential impacts. So this table, I can't quite see it, but I think I remember that it's all about. It's been proposed that your elasticity, how much an increase in cost would impact your volume, has to do with the value of the cargo. I actually disagree with that a little bit, but let's at least look at it here. So if we look at it in terms of the percent of cargo, it's not much for an automobile, but it really only comes up when we look at passengers. 5% of the cost for taking a cruise could be for the ballast water discharge. So that could be argued on a percentage of cargo value. What I think is a little more indicative is this percentage of cost of standard transportation. Moffitt Nickel did a report or a study for Port of Long Beach, I think it was, that was looking at increased container fees and what would that container fee look like. They proposed that for cargo that's discretionary, in other words, it doesn't have to go through Port of Long Beach, but instead it could go through Panama Canal or another location, that would be impacted directly proportional to the percentage of increased in shipping cost. So if it went from $100 to $110 to move something, 10% reduction in cargo movement. For non-discretionary cargo that was going to terminate perhaps in Southern California, it would only be 10% of that. So that $100 to $110 would only lose 1% of the cargo shipments. So here, as we look at this piece, we're at, actually, I'm sorry, I was on the wrong slide. I'll
Try to hook you up, Kevin, so you have power on your tablet.
Oh, but it's almost done, but thank you. Great. So here, we take it one step further, which is we then look at it in terms of the day rate of the vessel and what would be this increased cost and how many more days the vessel could travel to pick up cargo at a less expensive location. And the one that stands out there significantly is the bulker at 9.7 days. And so would our impact be quite high there? I really think so. If we're looking at 0.3 days, there's not a significant impact likely based on a day rate. So kind of a mixed answer here, and the mixed answer is there's a lot of cargoes that won't get impacted significantly, particularly those that are what you call non-discretionary. You need to move it out of this particular location. But there are cargoes that would be significantly impacted, especially those that are marginally profitable anyway. So in conclusion, treatment barge costs are significant in terms of cargo value, particularly if we look at that Stockton case. Or not cargo value, I don't think it's so significant in terms of cargo value. I think it's quite significant in terms of shipment cost. Without state controls, impacts will disproportionately impact outlier ports, and it will disproportionately impact cargo exports. Impacts will be greatest for discretionary cargoes, those that can be rerouted to other locations. And there's also the impact of if we are rerouting that cargo, that's more trucks on the road, and that's more rail car traffic, which is significantly less efficient in terms of air emissions compared to shipping. And finally, when we look at some marginal goods, I was talking with one of the port commissioners on the phone, and I think he used a case of watermelons. If you have a set of watermelons that don't really travel that well and you're trying to ship them to Asia, and it's pretty marginally profitable cargo anyway, trucking it 10 days to get to an alternative port really isn't reasonable. I'm not sure if it's damage in transit or the watermelons spoil. I don't quite understand why, but certainly throwing them on a truck for 10 days is probably a bad idea. And if it's now too expensive to ship them out of a California port, well, I suppose you probably just don't grow those watermelons anymore. All right, that's what I got. So sorry, George, for using more time than we're allotted, but that's the end of our presentations here.
feel like the student that's studying for final exams, and there's a whole coursework out there. It's like where to start. Let's go back to the discussion of solids disposal. One of the hypotheses that appears to be included in your report is that these are applicable for a traditional disposal landfill. Are there any precedents in that? Particularly, I am aware of dealing with some of the pathogens and things like that that may be actual viable within these sediments, as we understand the way the regs are written. You know, it could be a per gram or whatever. Can you comment on any kind of conversations or prior information you have on that? And then also to go back to, I think it was Steve or anyone, you know, we are somewhat worried about, you know, where you're going to do this and what kind of is this going to be something that you have to have has to be fixed sites for this and so forth. So just some general comments about the feasibility of landfill and meeting expectations of those permits.
Okay. On that, the assumptions that we made was, and this is through best engineering judgment without digging too deeply, was that the solids would be acceptable to landfills, and that was based upon thinking of the biological load living in salt water and then being applied to a landfill, that would be okay. But we did leave a caveat saying that, and I was thinking more along the lines of chemical contamination, depending upon where the ballast water is generated from, that may be an impact to disposability or where it could be disposed. Definitely if there was a deep water exchange, I don't see any impact to solids being disposed of. But I am more concerned about what happens if we know we don't do a lot of work internationally, but we know that, you know, in countries where there's a lot of economic growth and there's not a real established environmental protection agency or the like, that there are contamination issues. And then, but we made the assumption that it'd be okay, but trust, but verify. A verification of those solids would need to be taken.
One follow-up on that would be the salts, the salinity of that. Are there any regs in the landfills regarding that? I mean, it's sort of it's an odd thing to put in landfills, and I just don't know if you've explored any of that. That's my only follow-up on that question.
I worked a bit with Jean's colleague, Ryan Holloway, and Ryan did the calculations to look at the amount of material based on the concentration of the coagulant slurry with, I think he used typical seawater, 32 PSU, was not significantly salty. It was actually, he reviewed that and didn't see an issue requiring special handling.
Yeah, no, you actually asked a question. Steve, you've got anything? Not yet. Okay. Audrey.
Just sort of following up on the solids theme, there is some literature on the characteristics of the slurries in, you know, and I was curious if you guys had done any literature reviews, because people have tried to characterize these sort of waste streams from the point of view of can you recover materials and those kinds of things. But anyway, it seemed a little a little bit of a strong assumption without a lot of substantiation. And so I guess we'd encourage you to just at least explore the literature. And then the other thing is some landfills are operated as bioreactor landfills, and so the salt could, just like in a wastewater treatment plant, the salt could interfere with that biological process. So just finding those kind of places, near, that are close enough to the ports, I think is kind of a challenge, because why would people put landfills near the shore? So anyway, it just seems like it maybe needs a little bit more ground truthing, that concept.
Yeah, and I think in the 2020 timeframe, I think there's going to be a lot of, well, I know for a fact in the landfill that I visited in Orange County, that after 2020, they're no longer going to be accepting food wastes in the landfills, which is going to completely change the character of the landfill and the landfill leachate. I don't know if that would impact this or not, but again, in terms of futuristics, there's a lot of work being done in the state of California, I think, on landfills and trying to look at what's the future of these landfills. And I think it would be a good idea, at least to do some discovery of trying to figure out what's going on in that field. The other thing that I keep coming back to, I mean, you point out a dismal thing, like $3 billion. But what's the cost of doing nothing? I mean, how many billions have we spent in cleaning up the zebra mussels? I mean, I've heard as high as, $1 billion a year because I'm from upstate New York. I mean, $1 billion a year as a result of zebra mussels. Well, when you compare that to the $3 billion, it really doesn't make that number look so bad. And, if you were to be able to pass on those costs to the ship owners, which of course you can't, they would start to say, wait a minute, maybe we do need to do something. So I think that at least some statement about what the do-nothing costs would, if you had no treatment, what would these potential costs be? It just seems from a non-economic point of view to be something that would be worth exploring. So, because it sounds like a scare tactic. It's going to cost us $3 billion. Of course, that's over 20 or 30 years. So, but still, it's something that needs to be considered, because the no treatment option is really not an option at all. And it's because if we don't we've seen what's happened here in San Francisco Bay. 250 different invasive species in there.
So I'd have to say I don't know. I don't know if 3 billion is a big number or a little number in terms of, is this worth doing or not worth doing? I just don't know. I called up a long professional relationship with someone who runs a barge network of bunker barges. And I said, hey, got this number of like $35,000 to go do a call. Are we on Mars here? Are we on the wrong planet in terms of this cost? And got some numbers of what typical bunkering barge operations would cost in terms of what they see. And the short answer was, no, we're not on Mars, at least with the $35,000 number. Because they've got pretty good utilization. You wouldn't put a bunker barge somewhere unless you actually did a fair amount of business. And frankly, I ran a number by. I said, well, we've got billions of dollars here. He said, if that's what it, and this was just his opinion, it's like, if that's what it costs to solve this issue, that's what it costs to solve this issue. So if it came across in a report or in this presentation that it's a scare tactic or the sky is falling because it's $3 billion, that's not the intent at all.
No, I didn't.
I'm absolutely incredibly interested to see what the panel thinks and what the state thinks. So those are the numbers to the best of our ability, and there's some updates to do based on your comments. And very curious to see what the consensus is. Like you're saying, Bill, is that cheap next to the increase in efficacy and the reduction in risk to the state? I have no idea.
This might be for Peter, but really anybody. Thinking about congestion and port logistics, I'm wondering, there's an externality effect there on other shippers, and I guess that kind of begs a systems analysis, but it's probably very difficult to do. But I'm wondering, beyond a qualitative discussion of, certainly congestion will increase as we move towards barge treatment. Is there any sense of what that might look like quantitatively, in terms of maybe a model of, based on ballasting events, how many times or how much time would passage be limited in some particular way that would add shipping time and thus cost on either shippers or other port operations?
Yeah, I don't know how to quantify it. It's complicated, right? But I think the big issue to think about is not so much blocking waterways and will vessels be able to get by, because you can plan around that stuff, right? We have a concept of when vessels are arriving and leaving, and you sequence your ballast water treatment operation around that so that you don't impede the passage of somebody else. But where it's going to become an issue is when ships are pierside and they have to take lubes, they have to take stores, they have a bunkering operation and a ballast water operation. And the ballast water operation, in some cases for ballast dependent vessels, it's going to have to be concurrent with cargo ops, right? So everything else is going to get pushed to the end. So essentially, vessels are going to be spending more time at berth, and potentially staying into the berth window of the next guys behind them. Yes, so that's the externality that's imposed on those vessels. But how do you make predictions about what that looks like on a port-wide scale? I don't know that you can really do that, because every terminal is different, every operation is different. The more I try to wrap my head around this problem, it seems like there'd be a lot to learn from doing it, implementing one area at a time, right? Have a test area and see how does it affect vessels that don't discharge? How does it affect those that do? Yeah, so that's what I wish there was a way to measure it or predict it quantitatively. But.
I had a couple thoughts on that. Kevin showed some pictures of was it Stockton and some in San Pedro, and then I can think of other locations. For example, tankers seem to be a pretty significant volumes and whatnot. And for instance, in Long Beach, T121 is a tanker berth, and it's right off of the main channel. It goes into the back portion of there, and I think having that large barge there would, depending on the time frames for the treatment, I've heard several, a shift or more for those larger. I think that would have a pretty significant impact because of main channel things. And then Kevin and I were whispering about, one of the analogies for me when I look at this was similar to when CARB brought on the cold ironing requirements, and looking at how for all the terminal operators and those where CARB is saying, hey, within a certain amount of time of tying up, you have to switch over to grid shore power. And the operators are able to do that, and primarily I think it's just an added cost, but it does slow down getting the gangs working off of the cranes, because they kind of have to get out of the way. And so there's also those kind of operational impacts. It's not a true congestion, but it's still a thing that's slowing down the movement of goods.
Yeah, that's a really good point, Todd. So this would basically have to go on before every cargo operation, because the longshoremen would probably refuse to work those bays near the house until the connection is established. So ship operators would have to be, plan ahead and try to get these connections established before the 8 o'clock shift begins, and otherwise you're going to potentially delay the whole operation.
I'm just, I've been being primed to give you one example. You know, that one of the things, having worked with invasive species, some of these, the importance of the California regs in saying that they really don't want any virus and bacterial particles is so laudable. Because if you're looking with some of the economic insults that can be laid out, there's some recent studies, there's emerging pathogens in shellfish populations in Asia, for example, and there's a new study and worry that some of these could easily be brought to the West Coast and infect a lot of the growers and the natural populations. And so there are some estimates out there that could follow the concept of if you don't do anything, and why it's so important to have complete reduction in some of these units that the IMO and Coast Guard doesn't acknowledge at this point. So I think if we are dealing with the public with this reporting and need this to go to the boards that are controlling these, I think we owe it to the report to try to put in at least some caveats of if you don't do this, you know, what are some of the potential roads? So that's just a point that that Bill wanted me to make. Thank you.
We were talking about it the other day at breakfast, so.
Yeah, I mean, absolutely, we need to, it would be so helpful to make sure that this is taken in context, right? A cost without noting the benefit is very hard to digest. I would note that, what was it, NRC, National Research Council, in 2010 published their tropical pressure report, and they noted that if you can decrease the quantity, quality, and/or frequency of invasive species discharges, you reduce the tropical pressure. However, they were unable to quantify what such reductions do. So the tough part here is if we assume that the treatment systems that are for the federal and international standards reduce lots, 100,000 plus, down to few, less than 10, or, of course, down to 0, you've eliminated that risk. But it's so difficult to know what the increase in benefit is when you go from 10 to 0. If you look at the viruses and pathogens that you name, it's a little more nuanced. I don't have it at the tip of my fingers, but I want to say it's from something like 256 colony forming units to 70 or some number like that, from what you might have millions. So it is quite difficult to come up with a defensible, what is the benefit? If there was some way to say the benefit is worth $20 billion, that would be excellent, but I think it's hard to make that leap. I do want to try to ring the bell and say it's incredible that we have found, although some prototyping is needed, that we feel comfortable with prototyping and work that this approach can meet the California standard. And I think John Berg asked a couple questions that if we could allow Jean just a moment to talk about why Kennedy Jenks is comfortable that that very high standard is most likely going to be met, and how we could possibly measure it. If we could just allow him just a moment there.
Okay, I guess we're going to have to rewind maybe 2.5, 3 hours here. But I just mentioned at lunch with Kevin that I was chomping at the bit to answer John's questions, but we were just taking public comments, not responding to them. And I just wanted to note that his first topic was, how do we know that these these treatment technologies are going to get us to the California standard. And it was great to hear that because, as we clearly state in the report, we don't know. We are extrapolating off log normal curves of known technologies, and we assume that we use more energy, we use more chemical, we can disinfect to those levels. I think that's a fair assumption to make, but it needs to be borne out. We need to challenge those treatment technologies to show that we can consistently meet those limits. So that's number one. And then he also mentioned the sampling to verify the treatments. And that is a real challenge when you're talking about the low numbers, and we've talked about that at the previous meeting as well. And between the two meetings and in writing a couple of these documents, we took the approach that has a precedence in California in the potable reuse world, where you develop a log removal credit for a particular technology. So you set certain criteria for a particular treatment process to be operating optimally, and then you challenge that piece of equipment for the job that it's going to do, and then if it meets that, or however good of a job it does, or however well it works, you assign it a conservative removal log credit. So let's say, one log removal is 90% removal of these organisms, 6 log removal, or whatever the case may be. And then you add those up, and that gets you to where you need to be. And again, if each individual unit is meeting the operational criteria, you don't have to have a sample the final effluent every time to verify that it's making that standard. I think that would be the approach that would make sense in this situation. Doesn't mean that you don't verify a certain number of the samples, but it's not a treat and then sample before you can discharge. It's just not practical. You set it up on the capabilities of each individual units. So those were the 2 comments I wanted to make.
So you're really sort of talking about a multiple barrier approach, and I guess the problem is the report doesn't come across strong in the way it's written. It's very, we're doing coagulation and it's going to work. And so it would be good if you could amplify that, and really, what you just said makes sense. Just more describe, I'm not sure who's going to be reading this report, but just, you've got multiple barriers. Yeah, and so you want to explain it in a way, someone just said she was going to read it, but I'm sure many people will read it. But I guess my point is that, and this has been sort of said, is there's a lot of material here, and it kind of jumps around a lot, and so, but it would be nice to really explain it that way, and maybe even a diagram just showing these multiple ways in which you are inactivating the various pathogens, and the methodology for validating those steps, I think, is really important, because it's a broader audience than that maybe doesn't have the same expertise in that topic.
Noted. We can make that a little clearer. Yeah, sure.
A comment on that is the task report method is having 13 different reports is quite challenging to paint a cohesive picture. It's I would imagine, frankly, frustrating on your side, and I would note some frustration on our side. Task 5 probably gave those sort of explanations that you're looking for, and we didn't want to repeat too much of that, but we probably could have done a better job now in, I guess this would be, I don't even know what the task number is that we covered it. Frankly, no task between 6 to 13 was about the treatment method. It just kind of popped up a little bit in 13.
It was in a
other
small
analyses.
font spreadsheet in the appendix to one of them.
Yeah,
I think it was 13. Yeah,
but it was really covered in 5. So,
Right,
so I
right.
would say I would love to rewrite this thing into a comprehensive format rather than 13 separate semi-standalone reports. That would relieve the issue a little bit.
Right. I mean, the other thing that, just as long as we're talking about treatment is, it occurs to me that there's a lot of similarities between what we're trying to do with the ballast water and pre-treatment for desalination, because, and so some of the salinity actually can be a benefit from a particle removal point of view because you're destabilizing, and it looks like some of the assumptions are that the water, I mean, you have to design for a range of conditions, but it seems like some of the data on desalination pre-treatment could actually help build your case that, in terms of validating what might work.
Yeah, I think we received that comment last time from Christine, and we did incorporate, and actually initially, we incorporated some desal pre-treatment information to get coagulation doses into, but we took that suggestion and got more literature for that. But yeah, we tied that in. But again, there's a range there because you're getting, if you're not getting, if you don't have a deep water ballast exchange, you could have a relatively fresh water that you're treating. So you have to be able to have a robust treatment system that covers a range of TDS.
Right, and then the other question is, how do you even do the dosing? You have to have some methodology for doing that because it is going to be highly variable. That's why it sort of seems the stormwater analogy is also useful in that sense because stormwater is highly variable quality. So, but anyway, I guess just in terms of, because we're all confused and because it's come up, it seems that you might want to just think about how to communicate that in the report.
So it's 2:34, and we're on break for 4 minutes already. Do we have to break? Every time we go out this door, it takes us longer to get back into to shape here. Do we have to break?
I think the dialogue is so important, and we just don't have enough of it.
Okay.
Anything to continue it would be great.
Is that okay back there in the back? All right. So I have something I wanted to just kind of mention. I mentioned when I introduced myself that I just got done with 4 years of running the environmental engineering program at the National Science Foundation. And one of the last projects that I funded was using next generation genomics to get a complete scan within a water sample of all the viruses, bacteria, parasites, and actually also, what am I thinking? Yeah, and something else. But antibiotic resistance, yeah. The interesting thing is that genomics in the world of biology is moving ahead at a rocket's pace. This testing is going to open the door for direct potable reuse because we're no longer going to have to worry about, is it there or is it not? We can say it's there or it's not there. And I think that similar approaches, again, when we start, and you wouldn't know about this because there's been no papers out of it. I only know it because I actually signed I didn't award it myself. I never awarded anything, but I proposed that it be awarded and it was awarded. But the point is when we start thinking in terms of what's going to happen in 2020 and 21, there's a tremendous amount of work going on in water quality. This genomic work that we're talking about here is going to bring the biological quality up equal to that of the chemists. We've gotten to the point where we can measure things that are so low, there's no way we're going to ever understand the health effects of those chemicals, pharmaceuticals in particular. But there are some things on the horizon that are going to make determining water quality from a biological point of view much easier than we can do today. We don't have to worry about plaque forming units or any of that stuff, and we don't have to wait 5 days. It would be a day and a half at the longest. So that was one point. The other thing, I keep coming back to the Los Angeles Long Beach port. So I used to live in Southern California, and every day I would come up over the hill going down to the University of California, Irvine, and I'd look out in the ocean and see all these ships out there at anchor. That would be a perfect time to be treating their ballast water. Well, from the point of view, that's what I need to find out. All I'm just saying is they're sitting out there doing nothing, waiting to get in the berth. And there may be none of them that need ballast water treatment, but there's a lot of days that you could have a barge out there just sitting as they're going around their anchor. And it would then result in a lot less congestion in the port. Because as we all saw, the last meeting was down there at the Los Angeles. I mean, it's an impressive port. I mean, I think they get 4,000 ships a year there or something like that. And so I was just thinking that I don't know how you would do that, how would you quantify that, but it just is something that it appears to me to be something that we should at least look at.
Well, you can only take so much out without putting something back in. I think that's the crux of the issue there. Yeah, it's a great opportunity to do some deballasting, and perhaps some deballasting could be done out there with these mobile treatment units, similar to the deep water service station that I was talking about in Task 9. But generally, a deballasting operation goes on concurrently with a cargo operation.
No, I understand that.
Yeah.
Yeah, but if they're coming in with a lot of, well, and I know, we worked on a couple of big oil tankers, and I mean, the ballasting is absolutely concurrent with the offload of the 125,000 tons of
Right, some
oil.
of it can be done on an elective basis, which
Right.
what I'm suggesting is, hey, do it outside 24 nautical miles. Then it doesn't have to be done at all outside the breakwater.
You mean you mean like a ballast water exchange?
No, discharge to the extent that you practically can, but keeping a safe seagoing condition. And then you wait at anchor until you can go into the slip. So you've discharged as much ballast as you practically can without compromising the safety of the vessel.
Yeah.
And the rest of it would have to happen at the dock.
There's a couple little caveats to that. A vessel is subject to international, federal, and local jurisdictions, and there are the international, as the IMO regulations phase in, you're no longer allowed to discharge ballast water anywhere. Now, it's a little tricky because if you're outside 24 or 200 nautical miles, you're in international waters, and there's no cognizant authority over that. But your flag state, the flag that you fly, that you're registered with, does have responsibility to make sure you comply with that. So Peter's suggested discharge out would still need to meet those international rules. It's just wouldn't necessarily need to meet the California rules. Just want to be clear on that.
So you'd have to have some onboard treatment process, presumably.
Right. Bill, if your concept, if we just assumed that the vessels that were at anchor were able to discharge their ballast water, you're right. We would take care of what Steve was talking about. We'd have less of a peak loading, which is when they would hit the dock. We'd have that opportunity when they're at anchor. And what Todd just whispered in my ear was some of those anchorages might be due to labor issues, which slow down movements, or Christmas time or holiday season when you're moving more cargo. So we still need a system that's robust and is able to hit the ideal case where you're not laying up assets at anchor or just wasting money, but in fact they do go straight to the dock.
No, I understand that. I mean, I was just thinking that's an opportunity to, if they needed to have ballast water treated, that they're just sitting out there waiting to get a berth, so. Okay, anybody else?
Yeah, I just had one thing to add on the discussion on benefits, trying to have some measure of the benefits. I've done some work on trying to measure the benefits. There are some, it's mostly cost avoided. So you have some existing infestations that have certain costs, and you can use those as illustrations, and they are in the billions and tens of billions. And the other is the risks avoided. And one way to try to quantify or monetize that is to look at how much is being spent trying to reduce similar risk elsewhere, like TMDLs. And $3 billion doesn't sound like a lot if you're really solving this particular problem compared to the tens and hundreds of billions of dollars that are going to be spent trying to solve some other problem. So I think it's maybe taking a look at how much is being spent trying to reduce other types of ecosystem risks in coastal waters.
Right. Yeah, that's all I was saying. I think it's a great idea to try to incorporate that because your objective economic analysis is fine. It's just that, if we knew what the cost of doing nothing was, it would just make it look that much better because as the panel, we actually got together and there's none of us here that want, one more day of a contaminated ballast water being discharged into our waters. We will all want to see this thing move forward. And whatever we can do, I think, from a scientific and engineering point of view, to do that would be better.
I just want to make a comment that's an excellent point because I know of a single treatment plant that's discharging to the bay that's about 25 million gallons. So in the big picture, very small compared to this, and they're looking very creatively how to solve their nutrient issue because the only way they know how right now is a $500 million solution. So maybe they get that to $200 million, by being clever and by technology advancing. But when you look at that, is that a single treatment plant is looking at a $500 million solution, $3 billion doesn't seem.
Right, and then those are incremental improvements in achieving TMDL targets, whereas
Right.
we're talking $3 billion to really solve this particular problem.
Right, right.
Any guidance from, or maybe we get it later, just guidance from the panel on, would we be measuring the benefit from doing ballast exchange to California standard, or the benefit from the federal and international standard to the California standard? And I totally agree. Cost without the benefit is a very difficult thing to digest. Where do we start on the benefit?
I'll use that as a opportunity that, I can help you with some stuff, and I'm sure Nicole, there are a number of us around here that have numbers available that are more contemporary than the National Research Council and so forth. But while we're talking about this, one of the big looming issues is the Vessel Incidental Discharge Act, and how that might come into play in hampering California from using this approach. I think it's really imperative, again, to have this mass of information that demonstrates this, that can be used as a vehicle in congressional hearings even. I'd elevate this exercise to a fairly high level, that it has an opportunity to influence the public and also educate folks. So anyway, that's just a little bit there.
I think that if I was trying to pursue the question you brought up, I would be thinking in terms of the costs are really germane to implementation, which is roughly around 2020, which is roughly when onboard treatment's going to be happening. So it seems like those are contemporaneous, and that might be the appropriate baseline.
Now, I just wanted to mention that we do have some time. I want to make some time for public comments. And then after that, an opportunity for some final comments from the study team, Gloston, and followed by some final comments from the panel. And then also our Delta lead scientist would give us final remarks. So I want to call upon Nicole Borowski.
It's live. Okay. Good afternoon. My name is Nicole Dabrowski. I'm the Assistant Chief of the Marine Environmental Protection Division for the California State Lands Commission. I'm also the manager of the Commission's Marine Invasive Species Program. So we are the agency that has requested that all of you gather together and work on this study. I wanted to start by thanking all of you, and I want to thank the Delta Stewardship Council. I want to thank the Independent Science Panel and Gloston and all of the associates and subcontractors. This has been a long time in coming. This is the result of discussions that started in 2012 when we were looking at the availability of ballast water treatment technologies to meet California's discharge standards. And we needed a lot more information about whether or not shore-based options were available or could be available to meet our standards. And so this study is critical to the Commission, to the state legislature, to be able to make informed decisions about how to proceed with the implementation of our discharge standards. And you've all done a wonderful job, and I really just wanted to thank you on behalf of the Commission. I also wanted to give you just a little bit of information about the next steps of this once we have a final study. The commission is required to provide a report to the California legislature by July 1 of next year, looking at whether or not we can proceed with the implementation of the discharge standards on January 1 of 2020. So the study that is produced will be a critical component of that final report, where the commission will be making recommendations to the California legislature. So we will present the report to the commission. Hopefully, Gloston and Delta will be available to make an informational presentation to our commission in the new year, and then we will finalize the actual legislative report probably around June of 2018. So just give you a sense of where things are going from here. Just as an aside, I just wanted to make two little comments based on the discussion that I've heard today. For the January 1, 2020 implementation of our discharge standards, I know Kevin referred to it as a light switch. I do want to note that it's based on, for existing vessels, for first dry dock on or after January 1 of 2020, so it's not quite all the vessels at the same time. It will be based on their dry dock. For new vessels, it will be first time in California after 2020. The other thing I wanted to comment on was the underway discharge analysis. I know you guys were looking at the 24 nautical mile line. I wanted to point out that California jurisdiction is 3 nautical miles. So California's requirements only apply within those 3 nautical miles. Certainly from a biological standpoint, anything within that 24-mile limit is certainly going to be drawn into California waters, but in terms of our actual limit for where we can regulate, it is 3 nautical miles. So vessels that are doing an underway discharge at 20 nautical miles may actually be doing, may I finish? May actually be doing a ballast water exchange, an illegal ballast water exchange due to our coastal management requirements. So that's maybe something to look in there, that vessels may not actively elect to discharge to an offshore facility if it's going to be something outside of California's jurisdiction or even federal jurisdiction. Coast Guard lines only go out to 12 nautical miles. So just something to keep in mind and reflect upon when you're doing that, that portion. And I know this isn't really meant to be a give and take with the public comment, but if you do have any questions related to California's jurisdiction and the Commission's program, I'm happy to answer them. So that's the end of my public comment. Thank you.
Thanks, Nicole.
Thanks.
Sure. And I will be reading the report.
Word for word.
Yes.
We use the 24, and these are maybe some things that we should be a little more verbose and descriptive on. We use the 24 nautical miles because California is, can I continue? Because California is used that for air emissions in terms of when you need to switch over fuel, and we thought it was pretty perhaps likely they've been able to extend out the effective jurisdiction in air emissions, and this seemed to be somewhat similar, and that was our thought process in using 24 miles rather than their actual state waters, which is 3 nautical miles.
Let me see, you had something to talk about
Yeah, so we were talking about when you have some of the ships that are retrofitted with onboard treatment, but those aren't meeting the California regulations, then they would, and I think you guys mentioned it earlier as well, they'd become going through a double treatment, and why would they incur that expense? But we were trying to sort of look at different scenarios of these barges and how they'd be receiving these different water qualities. And so the question is, how flexible will the treatment system be to accommodate sort of the pre-treated water that's coming off of the shipboard system? And could you sidestep or bypass some parts of it, or have you kind of thought about how that would work?
Our big cost is going to be in building and maintaining the barges and the treatment plants, and transporting and having the personnel there on site. If you, for example, had deep oceanic or very clean water that came in that even underwent a federal or international standard pre-treatment and was neutralized, and it was just this very unchallenging water, maybe you could put a UV lamp from a high setting to a low setting, but I don't think it's going to change it might reduce your power. I don't think it changes your cost of your infrastructure, and I don't think it changes the cost of your operations significantly. I think that you need to design to, your nominal worst case, and that defines your infrastructure, whether you need to use it 100% of the time or only 20% of the time. Your overall operating costs are not going to be much less.
But as you transition to more and more onboard treatment just because of the requirements, then these might be oversized, say 10 years from now, because of that. So it just seems like it's a little bit of a moving target, right?
Of course, there's going to be some reductions, but think about the membranes. Jean could probably talk much better than I could, but you either need the membranes, which I think were sized nominally at 1 or 2 microns, or you don't. So those membranes, in order to get down to 1 10 to 50 micron organism per 100 milliliters, what's that, a 6 log reduction? You need these 1 or 2 micron membrane filters, and it doesn't matter I don't think that's going to change whether the water's been pre-treated by an IMO certified system or not. Then also so I think a lot of the technologies just to reach this level of removal are not going to change too significantly.
I mean, on the one hand, it's a conservative estimate, so that's probably a good thing.
It is conservative, yes.
But building in some flexibility to sort of accommodate changes over time in water quality as well as technology seems like that could be, in the long run, better, or so you're not stuck with some dinosaur, which is, which could happen.
Just to add to that, I think there's two toggles you could move. One of them mentioned is the disinfection technology. If you're looking at 3 log reduction versus 7 log reduction, you could have a lower setting for the UV or for the chlorine dose. The other one is if the water was filtered on board, you may choose not to add coagulant, and then just have basically the chamber before the membranes just to be storage just before it goes through the membrane. So I could see there being like a treatment light, but that would be used under the assumption that the ship conducted the treatment and did it properly, and those waters meet those international standards. So it's a little tricky. It gets a little tricky because that's all real time. It's not like you can take a sample and ship it off and then know what you're starting with. You have to make assumptions.
But I guess it also affects the hydraulic retention time, which affects the time the ship needs to be connected, right? So by streamlining that maybe could have some cost benefits, right?
Yeah, it could.
And that maybe could provide enough incentive to encourage the use of the onboard systems. There's many different ways, but I guess part of our thoughts are it would be helpful to map out a few scenarios of like these different, instead of just sort of generalizing, it would be helpful to kind of simulate or help the reader walk through these different situations and how they might impact your bottom line, perhaps. Because you kind of know them implicitly, but the readers don't, right?
Noted. Thanks.
Steve, do you have any other questions?
No.
Absolutely. Go for it. So one of the topics that our panel's been discussing at length is a lot of the analyses were based on a fairly short set of data. You chose a 5-year period and you downloaded the data. And even just yesterday, we heard each year in Stockton, they're meeting, they're breaking their records from last year. So we were concerned about over-reliance on such a short data set and perhaps expanding that, or at least creating some boundary conditions and bracketing that a little bit more would shore up some, it's safer to have more conservative estimates than to try to, to try to minimize it. And so I guess we would encourage you to be more comprehensive in the data that you've used for inputs, or at least kind of do some more statistics on it and come up with, more of a bracketing of that.
Or even to provide that as an appendix. I'm a data miner myself, and it would be really nice and very transparent if, just to use an example, there's a recently published manuscript by some fairly strong scientists that revisited the analysis that was done by EPA on meeting the Coast Guard elevating the guidelines, and they came up with a different conclusion than the EPA Scientific Board did. And so in light of transparency, it would be really nice to put that into an attachment and appendices so that we could see it, and anyone could.
I guess to amplify that, there actually is the Open Data Act, and if you're working on any federally funded project, you have to make your data accessible and curated in a way that not only it's a hard copy, but people can actually access that data. So there's kind of lots of tools being developed to help with those data analytics, and it would be really helpful and less frustrating to the reader if they could say, let me just look at that and see if I see the same thing, or so you have it, so why not use it?
Yeah, no problem with sharing all the data. All this data comes from frankly, the Coast Guard database. It's really just a matter of how you process the information. I think I'm a little concerned with going earlier than 2010, because then we're into the Great Recession. And I think those numbers, while maybe historically could predict that there's going to be, how long has it been since the Great Recession? Maybe we're heading towards another one if you follow the calendar. So maybe that's information that it could decline.
So it's those trends that we're kind of eager to learn more about, as opposed to trying to take averages, and because we want to be able to see, and then that gets into the scenarios. So what if there is another recession? How will that trickle through this whole process? And so we want to kind of ask those kinds of questions now versus trying to sort of ignore them, because it's kind of there. And you had to choose something, but the data are out there, and the analytics isn't that much more complicated.
Sure, great.
Are there any more questions from the panel? Let me just rehash where we are. We've actually gone through the public comments. We've now basically concluded the panel's questions. And now we have three final things, final comments by Gloston, final comments by the peer review panel, I guess that's us, and then the Delta lead scientist is going to close the meeting. Is that okay?
So before I call upon the final comment period here, I just want to mention that this being the final meeting, what happens after this. So the panel has, within about 2 to 3 weeks, will get their comments together. They'll probably meet.
Gave us 4 weeks.
4 weeks. And then they will send it to us, and we'll have it posted on our website and transfer it to you folks. And then the study team has about 30 days or lesser to bring back the final report, which will then have it on our website. And then after that, we will present it to the State Lands Commission. And then the routine after that. Nicole just mentioned what happens after that, so.
I did want to mention just one last thing. We did get a comment from Rick, unfortunately, who couldn't get here. And his comments that he provided us last night actually were very similar to the ones that we'd already talked about. He felt that the report was adequate, and he had no red flags whatsoever. Is that correct?
I actually have them right here. I can read them.
Okay, yeah. I think that's appropriate.
Okay, so pretend I'm Rick. And so his main comments were about the data, And then it says, "It would be good to learn more about how they establish the numbers, frequency, utilization of the barges that they concluded would be needed." So he's referring to that table where or the picture where you have the different numbers of barges. Just providing the data there would be helpful. Instead, your conclusions are good, but just substantiating that somehow. There will certainly be times when arrivals bunch up and overtax the ability to service all demands in a timely manner. One other concern is how they arrived at the treatment cost for the barges, since there's no evidence to date that the California discharge standard can even be met, sort of our discussion earlier, or how measured. And then perhaps qualification testing of systems needs to be performed long before cutting steel to construct barges. So it kind of summarizes, even though, so he's here, kind of summarizes the whole discussion in 4 bullet points.
All right, good. George?
Great. So let me call upon Gloston Incorporated for the final comments.
So just making some general final comments, and I'll invite our group to fill in any open items that they have there. Very pleased to present these final draft comments, and the comments back from the panel are much appreciated. Heard loud and clear on providing the data so that you can process it for your own purposes, to verify what's been performed. I think Rick's last notes there, that it kind of falls in line that we need to be a little more conservative in the timeline. In other words, while we're comfortable that a treatment barge can in fact meet the California interim standard, it's not proven yet. And to have that as a pilot project and building that into the timeline, I think is quite an important thing to do. And we'll pick up that item there. Just a little bit of a procedural item. It's difficult to write 13 independent task reports and have them glue together in a cohesive manner. So we share your frustration there. We'll certainly talk to the council to see if there's something we can do about that. This has been an absolutely fascinating subject to dig into. Everything from the incredible support from Kennedy Jenks on what can treatment technologies do? How can we count the uncountable? So absolutely fascinating. I came into this not knowing if it was possible to meet the interim standard, and what a great education to learn and understand that it's possible with these shore-based technologies. I was quite concerned in terms of land-based piping and building new wastewater treatment plants. A whole lot of work with KPFF and trying to lay out pipelines, and how do we get rights of way to lay this out, whether you're in a very small port or an incredible complex. And we just were so afraid not afraid, just so uncertain of giving those terrible answer, which is, yeah, geez, we've been working on this for a long time, and I don't know if it's possible or not. Maybe, maybe not. What a lousy answer. So taking that very extensive exercise to look at the barge-based compared to the land-based, and seeing numbers come out that really pointed to the barges, where we could look at it and point at it and say, yeah, we put barges alongside ships all the time, and this is something that we can present in front of you and say, we can do this, we can grab that water. So that was an important bump to get over in this process. Looking at the legal aspects, understanding parts of the permitting, again, quite interesting. Trying to understand port congestion and impacts that way, again, another fascinating turn. And perhaps at the end, one of the most difficult to wrap your arms around is, what are the market impacts and how do you quantify that? I hope maybe in the panel's closing marks, Steve will lend a little bit of wisdom and thoughts on what he thinks of those parts there. With that, I just open it up to other members of my team for any closing thoughts or comments.
I'll jump in for a second, Kevin. And I want to speak to the question about the data, and could we go back and expand the data set a little bit so that we're getting a bit broader picture of activity over California ports, right? And we can absolutely do that. It's more difficult to forecast shipping activity. Historically, this is something that folks really struggle to predict even more than 1 year in advance. There's so many factors at play that drive, it's an international business, and there's many different market forces at work, and so that's truly difficult. But if we do go back and expand the data set, I think what it's going to show, and the answer might change a little bit in terms of, we might end up with 9 barges in LALB versus 7. We might end up with 5 barges in Carquinez instead of 4. But the answer is the same. It's and that's what I love about the barge solution, is that it's moldable, right? You can adapt these individual zones so that they can move up and down and meet changes in demand. Because I'll tell you what, the data that we don't have yet from 2016 to 2020 is not going to look like the data from 2011 to 2015. But our team is really comfortable that what we've put forth here is something that can deal with whatever those numbers look like. It just may mean shifting barges from one zone to another, or constructing additional barges and popping them into service. But I feel like we've landed on a good solution here.
I'll make some final comments. I just wanted to thank the panel and thank the Delta Stewardship Council. I really feel like I got a couple really good comments here that we can take the draft TMs that we're responsible for to a more understandable place from the reader's point of view. And thank you for that. I think that, and look forward to the comments in 3-4 weeks. But to make sure we're on target with what I've heard in the notes that I've taken. And I just wanted to just express my thanks to the team too. I usually work with my feet on solid ground, and it's nice to go out to sea here. And a couple times when trying to figure this stuff out, I felt a little seasick, but but I think I've gotten my sea legs, and it's every time I interact with these people and come to these meetings, I learn an incredible amount of information about how you could possibly do this on the water, and that's just really fulfilling to me on a personal, professional basis.
Kevin reminded me when he started talking about the pipe network.
Speak up.
The pipe network brought back memories. I think at the last workshop, and I talked a lot about, that there's a number of challenges doing the dockside modifications if you're going to take the water onto the shore, and that they were costly. But following that, when Kevin asked me to start, what do you think the pipe network we need, and the number of nodes and the tanks, and you look at little dots on this map, but to realize that thing might hold 8 million gallons in a tank, and channel crossings and those kind of things was really like put those what I thought were big challenges at dockside in a little bit more perspective. So I think conveyance was really what helped convince me that the barge network was really a pretty viable thing. I suspected going in that in a compact port that it might have some advantages, but it's been a really fun mental exercise to go through the study. So I appreciate the opportunity.
Unlike John's getting his sea legs on the chair here. We'll have to take you out to sea, man. I can see that for sure. There's a lot of difference between getting your sea legs out there and sitting there.
Just one general comment. I thought it was Glosson did an amazing job. I'm not sure where you'd find the combination of expertise with the insights into this, but I've worked with a lot of engineering groups, but the idea that they actually did 2 projects. They did the shore-based, and then in the spring shifted gears to a completely different approach and did the same analysis for that, and came up with a lot of insights that I don't think you'd get in many other teams.
Good, thank you.
Again, sincere thanks, and this has been a great trip. We'll finish up the report, and when you do these things, I really feel like we ended up with the answer, or we answered the question, and I hope that that comes across. Sometimes you do something, and you're like, you hate the, well, we're not so sure, or 50-50, and in this one, feeling quite confident that this is a technically feasible way to meet the mandate. Thank you.
Thanks, Kevin. So basically, the technical issues are all solved, but the economic ones are not, so I'm going to defer to Steve to talk about economics.
I thought overall it was really good. I thought it was a good study. There's so many things that are unknowable. You know, with regard to Humboldt Bay, I think that's the one of all of them that, you know, I think that there may be potential for shoreside storage because I think that the cost is so high to service Humboldt Bay from San Francisco Bay. And just knowing that area, there's a lot of underutilized shoreside parcels that are owned by the Harbor District there. That might be something worth some thought. There's a former pulp mill site in particular that may have a footprint. There's an outfall pipe there. There's a lot of interesting infrastructure. But overall, I was really pleased with this and learned a lot in the process. And really can't put my finger on anything right now that would say, you know, here's something concrete that's inadequate that you need to change. So, thank you.
Christine? It's going to pass. Okay, Audrey?
Yeah, overall, I think it was a really amazing amount of effort and really, you know, and really covered a lot of water and ground. I had just a few other thoughts that kind of came up in your comments. Peter before had mentioned, you know, kind of wishing there was a test area, and it seems to me it could be possible to do some model simulations, visualizations, you know, I mean, just to kind of explore just the logistics of you know, of the comings and goings from these ports. And it seems like, I know it's sort of, the project's over and that's not in the scope, but it could be something to think about for the future, just having some sort of model that you could use to simulate the you know, and to help optimize the system.
And you guys are in your closing comments. Am I allowed to?
Yeah, go for it. Yeah, we're all friends here.
I think that's a fantastic idea. I think that's something that would absolutely need to be done when this thing moves from a feasibility level to a, okay, we want to now really explore this and how to implement it. We've had similar things in Puget Sound, you know, like a vessel traffic risk assessment where we look at the movements of vessels through and we add greater and greater numbers and we assess the risk. And I think you could develop pretty sophisticated models to look at things like what are the externalities that you're creating? How are you delaying vessels by how much and how often? And you could model it. It's not part of this study, but it's I think would be really important to understand before you just go cutting steel, as Rick says.
Yeah,
And
you
just
could do it. Go ahead.
It would allow you to look at future scenarios of greater or lesser traffic. I mean, I agree. I think that's an excellent idea.
Yeah.
Be a great follow-up.
I mean, you know, you can do all sorts of simulations, you know, virtual simulations, but I used to work at the Waterways Experiment Station on the Mississippi River, and they had a 3D model that you could actually put little to scale. And sometimes those things are so helpful to learn and also from an education point of view. So just something to think about for the future. The other thing that Peter mentioned before was that about forecasting the future, and certainly that's true, we can't, but it would be helpful to identify some of, you know, because your comment was it's complex, and yes, it is, but it would be just helpful to just in a coherent way identify some of the different drivers or the factors so that it's not just saying, oh, we can't do it, it's too complicated, but just, you know, in a diplomatic way, just kind of put how these different variables will affect the outcome or a recession. I mean, there's too many unknowns.
Sure. We know what the factors are. It's just there's a lot of them.
Yeah, I mean, don't put them in a long list in small font, but, but if you could at least sort of, in a way to help, again, the end users of the report, help them sort of visualize how things might be, what are the sensitivity, and you could probably do some sort of a sensitivity analysis on those factors, and so it seems like that could be worthwhile as well. But I think, in general, we all want to make sure that we don't have invasive species, so we all want to keep our eyes on the prize and figure out how to get there. So I think that's, I think, what we'd like to see in terms of how this is presented to help people make those decisions in a scientifically based way.
And just a little response to that, Audrey. Dennis and I were chatting at length during lunch and even before. It's pretty atypical that we would have put out like a single number. It's much more typical to look at, what's our sensitivity, what's the worst case, what's the best case. The trick, of course, is probably just a straight up sensitivity doesn't do it. You almost need a rather sophisticated model that would look at not only what if we could turn the treatment system down because it's already been treated with Coast Guard or IMO systems, and we're in a recession so that the traffic is down, and the price of fuel and additional ballast water discharges. Really, we shouldn't be. It would be nice to not be having a single number. It would be much better to be looking at a range of numbers based on a more complicated models. At this point, frankly, it was such an enormous task to get just some straight up arithmetic numbers, and we just haven't had frankly the time or resources to build those models. But it's really what deserves to be done with this sort of study.
And I guess you could plant some of those seeds in the report. Obviously you can only do so much at this point, but.
Let me just add, as somebody who builds a lot of these models, you really couldn't build a model until they did what they did. I mean, there was no basis anywhere that I know of where you could do it. Well, now you could. So you can use where you could just plug in a number, and if you see a headline that you think is going to change the future, you can change it right there and see how it affects the results.
I have a question, probably to Delta, to how we roll this out. I would like to see a very solid executive summary. Kevin talked about the difficulties, and it is difficult. And in order for Nicole to give this to a commission and all of those things, and I think I think it would be appropriate to have the panel help weigh in on, how to be. I mean, we're all the peers, we do this for our living, to make it as clear as possible to the people that are really going to need to digest this. And I think we owe it to our mission here, but I would leave that to Delta to figure out how that can happen within the timeframes that Nicole needs and so forth.
I think you're up.
Okay. You don't have any?
Nope.
Anything there? Okay. Well, so thanks again to both the panel and to the crew that has put everything together. As we heard, I think the panel has good feelings and strong feelings about what you've put together. The notes that I had jotted down, pretty much everyone covered. So I think an executive summary is definitely something I think that would be very useful. And maybe an extended executive summary, since you have 13 pieces, really making sure that the clear message of what is most critical from your report, both to the State Lands Commission and to the broader audience, really would be an essential thing. One message that I heard this morning was flexibility really is critical, and I think what Steve mentioned, clearly the barge solution seems to be the preferred approach, but there probably are cases where it may not be appropriate, and so I think highlighting some of those issues of where you think that different options might be considered. I really also liked the discussion that came up right at the end about using the models. I think clearly that can't be done now, but as was indicated, putting some of that into the report to indicate what next steps may be and how we could go from where we're at currently to more specific recommendations down the road, I think would be really useful. So those things, I think the executive summary, sort of the flexibility issues were the main things I wanted to emphasize. I also want to just say, as everyone has said, it's been a very productive process. I learned a ton. I'm definitely interested in invasive species. When I was a master's student long ago, my research was on an invasive plant, Spartina alterniflora, that's a big problem in San Francisco Bay. It's clearly probably not spread through ballast water. Actually, it was spread by the Corps, as that's how it got around. But because I did that work long ago on invasives, I've always been interested in following along with those challenges. So I've learned an enormous amount about the whole process. So I think it's been a very, very successful. So George, do you want to add anything just to close out?
I happen to love Spartina alterniflora, by the way.
Yeah.
On the East Coast, it's really a cool plant.
Yeah, there's people who think maybe it's a good plant everywhere with sea level rise.
Right, right. Well, we were doing some work with atmospheric sulfur, and it's actually a big player in that.
Yeah.
So, thank you very, very
Thank you
much,
all.
everybody. It's amazing.
We can all go home early.
Woo-hoo. Thanks again to all your hard work, and we will get you a report in 2 days, was it?
Well done, I've been working on it right here in real time.
So, and then, of course, we expect an immediate turnaround as well, so. So thank you very, very much. It's been a lot of fun, a lot of work, and an awful lot. We've killed some trees here, too, I can tell you that. So, thank you very much. I think the meeting is adjourned.